Everyone, not everyone, but a lot of you seems to survive yesterday, which is good. Give yourself a round of applause. You made it here to the first session. Awesome. We're gonna start with the first speaker, but before that, we will give everyone in the other room. Can you hear us? You have to applaud a little bit more so they hear us in the other room. 1, 2, 3. So everyone in the sponsor area, you have to get back. Get in here for the first session. It's about to start. Did everyone enjoy last night? Nice. Did you play any pinball? Yeah, it was a little bit laggy though. I didn't like that. You need like the manual stuff, like the old school thing. You were too drunk. Good. Then it doesn't matter if it is like a digital one or a normal one, right? Okay, so we're going to introduce the first speaker, the man, the myth, the legend, Fredrik STÖK. So, yeah, give it up for Fredrik.
Good to be here. All right, it's good to be here. So, you guys survived last night, and I'm happy for that. So, we're going to start with, obviously my presentation couldn't be there, but fuck that. So, instead we're going to do it like this. So we got to get some energy in here, a little bit. This is Hooja, so here we go. Hands up! That's good. Perfect. It's Friday. Woo! This is Epadunk. It's really good. Hi, I'm STÖK, and I think it's a bit of feedback. Can you help me with that? Thank you. Awesome. Hi, I'm STÖK, and this talk is going to be about a lot of things that you would learn that's going to help you to, in the end, find vulnerabilities, hopefully. So, when I'm... So I used to create a lot of stuff on the internet, like YouTube and stuff, and travel the world and hack and doing all this cool stuff. But now I fight cybercrime over at TrueSec, and I really enjoy that. And this is Peter. He's my friend, and he has built this amazing automation in Rust that scans the whole internet, finds vulnerabilities at an insane amount of requests a second. And he finds shitloads of cool stuff with that. But that's not what this talk is going to be about. Because it's going to be about this huge one-liner that I created. So you can kind of do what Peter does, but as a one-liner. Because to be honest, I can't code for shit.
Hold on, wait. Are you saying that you can't code?
Yeah. But I dabble with code. And if you do, I copy-paste things from Stack Overflow, and I ask ChatGPT to, show me stuff, and I realized that fucker can't code either. So we're in a situation where I have this idea about these grand designs that I want to create that's going to be super cool automation that's do a lot of things, and they always end up in this state, unmaintained, crappy, and, not really the way that I wanted them to be. So that's why I love tools. And I love people that create tools so I can use them, because I don't need to know how to forge a hammer to use a hammer. And I also don't need how to learn how to code to chain a bunch of hammers together to get things that I want.
Okay, fair. I get it. It's a fair point. But seriously though, are you just going to stand here and talk about some cool GitHub repos, or actually going to show us some real hacking?
Well, ouch. Thank you for that, Giant STÖK. That's the way to start the morning. Fucking burning your friends and all. Yeah, that's actually what we're going to do. I'm going to talk about a lot of cool repos and not show you any real hacking, but I'm going to inspire you. So the day when you're sitting in front of your computer, you're having your hacking day, or let's say that it's the keep the internet safe kind of day, where you're sitting in front of your computer and you feel like, oh, today is going to be the day when I find awesome bugs, or the day that I protect my organization. You, like me, probably have a very limited amount of time. And if you're having kids, you definitely have no time, and an angry wife. So when you want to hack, it's like very, very limited. So you need to be selective. So let's imagine you went on Project Discovery's website here, Chaos, and you wanted to, poke at Yahoo, for instance. So you download their package, you cat that through, and you realize it's 5,865,241 subdomains for you to choose from. So how do you choose? Well, you funnel. Like any kind of marketing thing, you put things in a funnel, and eventually, it's going to go through that, and it's going to end up with fun times. So that's what we're going to do, and it's very important to do that. And just so every one of you in the back understand, it's puts the recon in the funnel, or else it gets the hose again. Because we want to remove the noise and focus on the interesting stuff.
Interesting stuff? So you're saying that we should look for interesting stuff?
Yeah, exactly. And interesting stuff depends on what it is, because interesting stuff are things that you like to poke at, or maybe what your organization wants you to poke at. So with that out of the way, we need to automate all the boring stuff so we can hack and have fun and do the cool stuff. So let's pick a target. In this case, we're going for Uber. Why? Well, they got a great bug bounty program over at HackerOne. They're helpful, but they have a star.uber.com policy, which means anything that's not in their out of scope list is in scope. So it's a good training ground for us to show what we could do. And a way to do that, where we start all these adventures, is that you probably have some kind of root domain that you need to start poking at. And a tool you can use for that is Subfinder by Project Discovery. And the cool thing with that is that you can populate it with a bunch of API keys, like if you have security trails or Showdown or whatever, it's going to get that passive data too and help you put that into your recon flow. And as you see here, I'm piping Subfinder with the domain that I want and piping over to a new. And for anyone that hasn't been using a new is like T-A, which means that whatever output you get, it's going to append it to the file. But a new sorts it and only displays the things that aren't already in your file, which is great because we're only curious about the change when we're doing this automation flow. Obviously, you can use the mass and some other tools that are way, way good. But we're focused on using these tools for the one-liner now, so let's do that. Okay, we run that through. We get a bunch of hosts coming out, and we're happy. And we realize we have somewhere around 11,000 hosts for us to start to dig in. Tad bit smaller than Yahoo, but still good. The question is, does they exist? Does they even resolve? So we need to do that too. You can probably do that with Dig and just look up for something else. But we're going to use a tool called DNS to get the responses out and send those over to our IP list. And now we're funneling down, and instead we're having somewhere around 1,800 hosts that respond to our DNS request. 1,800 hosts doesn't seem that much compared to 11,000 we had, so maybe there's some fishy thing going on here. Could it be DNS? Hey, let's add some resolvers to the game. Trickers has this really cool list of updated resolvers for you to get. I think it's like 50,000 lines or something, and they update it every 2 days or so to see which ones work. So we're going to add that one too. And in this case, we're using the -R to get the resolvers in there. And now you can see we're doing the new, and we're getting even more responses back. we got about 3,000 new responses, which means we put in things in the funnel. 1,800 was enough for us. We need more things to hack on, but we had somewhere around 3,000 with resolvers. But we also got about 495 unique IP addresses. And obviously, if we have an IP address, it's going to link somewhere. So we need to do PTR. We need to resolve it back again. You can either do that by getting the output with DNSX doing just RO, and it gives you the output of the file, or you can grep and awk it. But in a way, you need to have this list of files, IP addresses, that you want to put in the rest of your automation flow. You can do that with host or something else and do a little for loop. Or you can use DNSX for this as well and do minus PTR, RO for response only, and hey, we got a bunch of new addresses to put into our list. Bit of disclaimer though, from now on, things are a bit more risky. Right now, you're not doing anything illegal. Now we're stepping into the boundaries of if you're poking at things that are not yours and sending a lot of traffic, that's going to be a problem for you. Because we're going to start DNS brute forcing. Because we want to know even more things about the domain than they gave us. We need to find the juicy stuff. So there's a tad bit chance you're going to get an abuse letter by somebody if you're doing that. And they're going to be very sad that you did denial of service on their DNS because they only have a crappy one and didn't distribute it. But YOLO. So we're going to do that. We send this one in here. And I cleaned this one up using a sed command where I'm taking all the subdomains that I have, and I'm removing the dots and the dashes and the numbers and everything because I don't really want to have something that's called API server -something.53 in my brute forcing list. I want to create my own version of that because maybe they have a 54. So we're going to send that over to a tool by Codingo called DNS Cool. And it's really, really nice because all you need to do is to have this list of domains that we collected, and we're giving them a root domain. In this case, we want to do dev.uber.com, right? And it's going to create a huge word list for us where it contains about 19,000 new DNS lookups for us that we can run it through. And it's going to give us that in the format with dashes and numbers and everything. You can tweak this to the end of the day, but it's a very good way to create the brute forcing list for DNS, since we're using words we already know the organization is using. And you can just populate that Uber domain with a bunch of internal stuff too. And I know, I'm using Nano, but this is my way of exiting Vim, so that's why I'm sticking to Nano. And as you see here, we run that again, and we got a bunch of new addresses coming up. That 10.0.0.1, that's interesting, right? Internal resolves. Could be fun. When we're doing this at a massive amount of a target, maybe we want to be able to we don't want to sit there and look at it. We want to be notified what goes on. So we can use a tool called Notify that's going to send whatever output you have of the tool to a bunch of different platforms. So maybe you would have a Discord bot giving you the results coming out, or your Teams chat or Slack or whatever, because you want to wake up in the morning with fun results to poke at, not having to go look for them. But we also need to do a bit of port scanning, because content discovery, port scans, they all go together. And scanning about 65,000 ports, it's going to take about 10 seconds on a local Nmap machine, using Nmap on a local machine. But it's going to take, but imagine it take 25 milliseconds over the internet. It's going to take about 4 hours. This is a long time for us to do a verbose testing. And that sucks. So we need to dumb it down a bit. And in this case, we're going to select a bunch of ports that are known ports. And we're going to use a tool called Nabu. And Nabu is also from Project Discovery. It seems like this talk is all about Project Discovery. But they're making cool tools and go. So I took the list from Mitch in Aquatone, because it's a good list, and added some more stuff to it. And
dude, seriously? Nabu? Why aren't you using Nmap or Masscan or some of the other tools that everybody else uses?
To be honest, Nabu also have this passive thing where you can add more API keys, and if you want to be stealthy as fuck and not poke at the target, you want to collect data, and it does that for you. And you can collect that and have access to a lot of cool stuff. So, you know, hey, good times. And also, Nmap has a little bit of a commercial thing where you need to pay if you're using it inside your product and such. And obviously, none of you would use that in a commercial setting, but to make sure that we're not having that situation, we can use Nabu. And Nabu does a run over first of all the IP addresses, and if you really want to use Nmap, you can use the nmap-CLI to send it over to Nmap, and once all the ports have been scanned, it's running the Nmap scan. It saves you a bunch of time. Hey, homie. But we're here to hack web, right? And hacking web is the shit. Port scanning is just part of that process. And a way for us to know if there's a website active on it is to use a tool called HTTPX. And it's really simple, because whatever domains that we found, we can send that to HTTPX, and it's going to make it's like super fast curl in a way where it just collects data. And we're going to filter out stuff that we like. We want to have the status codes, what kind of server is running. We want to do some fingerprinting to collect that into a file so we know what's interesting for us to poke at. If we like to poke at, like Dan talked about, IS 8.5, maybe it's good for us to know which servers have that. And if you used to use, oh, beautiful. If you used to use tools like screenshotting tools, that you don't need to do that anymore, because you can use it straight into HTTPX here or Nuclei or whatever, and it's going to give you the output straight into the file, which is great if you want to render the DOM, right? See if your payload fired or not. So once we have all these active domains that we know are answering on the server, we want more data, because data is the thing we can make decisions on and find vulnerabilities in. So we need to crawl them to find what actually goes on there. And there's a bunch of different things to do. I'm using GhostSpider in this case, where I'm sending all the live sites over to GhostSpider. It crawls it, and it saves the output into another file. But you can use Katana or Hackcrawler or any other tool that you like. Katana is cool because it's headless. So you can get a lot of really, really nice stuff out of it. And you can even have this mode where you're looking, you can see where it renders in real time. So you can kind of look at what it's crawling and how it does it. The output gets this huge file, and obviously, that can take some time going through. So we can use this tool called Unfurl by Tom Nom Nom instead, where we'll say, whatever is in this file, look for a URL and display it in a format without any parameters, because we're only interested in endpoints here. So we'll get that. And it also have this possibility, if we want to do, maybe we're interested in fuzzing this for getting parameters, we can use this as key pairs instead, or keys or values, so we can get those juicy parameters that we want to poke at. And once we've done that, in this case, I'm sending them over again, a second run on HTTPX, but I'm only sorting out 400s, 403, and 500s, because I want to have the fun. I want to see the stuff that they don't want me to see. Because once I've found those endpoints that people say, you're not allowed to go here, I'm going to fuff that to make sure that I will get some other things that they missed to secure. And one way to do that is to use 6 to this list, because it's the one for all list. It's really, really good. And the micro version of this, 25,000 lines, contains a lot of really good endpoints for you to fuss, and that will give you an idea of the target, right? And I did that, and I had a good time, and then I realized, shit, I found something here. So I went down a rabbit hole and hacked instead of doing this presentation. Sent a report in, fun. Here's a picture of me when I was young. I'm kidding, this is me in the 90s, pretty badass too. And why I'm showing these pictures is that because whatever goes on the internet kind of stays on the internet. And that's why we used archives. So web.archive.org crawls and snapshots the internet all the time. And since we like to look at Uber, we can see that there's a bunch of iterations of old stuff that's been collected there too. It's all in the archive, and it's accessible for us from the command line using GAU. And GAU is get all the URLs. Corbin wrote this pretty cool tool, and I mean, we're not really interested in their PNG files or fonts and shit, so we just sort those out at the blacklist, but we're very, very interested in finding all these old endpoints that they had. So we ended with about 1,961,000. That means that, why? Because if you remember, it puts the recon in the funnel, or it gets the hose again. Because now we're putting it back on the top, we got more fun to poke at and break down. And maybe out of all those endpoints, there will be something that has to do with SSRF, because we're really, really interested in finding SSRFs, because those are cool. Then we can use GF by Tom Lanon as well, and GF patterns by Indian Leet, which is a grep format that's already populated with a bunch of parameter names that are common in the reports. They dug through all the HackerOne reports and looked for the ones that were connected to these ones, collected them, put them in the list, found, bam, cool. We want to have that. And out of that, apparently, we have a bunch of next URL stuff and some other things that I'm not going to show on this image. But hey, you get the idea. This is us going from 1 million endpoints to 600. That's manageable. We're funneling down. Now, stretch. Arms up. Because there's a lot of fucking technical shit going on here. And I don't want you to fall asleep. Because we're heading into the land of JavaScript, which is the gold mine of everything if you're hacking stuff. And collecting stuff from the internet is good, because developers like to do things and put them in JavaScript files and forget about that they put them there, or they didn't know what they did. And a great way to collect those is to use sub.js, for instance. It will crawl whatever site you have, collect all the JavaScripts, which is great for us, which means that we can take all those JavaScripts and save those somewhere. We can even grep through the whole GAU selection of 11,000 files that we have, and we'll end up with somewhere around, what was it? I can't read that. 34,000 JavaScripts, unique. Because we didn't do the parameter thing on the end, you know, that noisy thing with a lot of strings. So that's going to be a handful. But we're going to send those over to HTTPX anyway, because we want to see which ones of these respond, and we want to save them to an output directory called, in this case, Uber.js. Because there's another tool, a lot of tools, that's called Extend Link Finder. And it's an iteration of Gerben-Leo's, it's an iteration of the classic link finder by Gerben. And it's really, really cool because you can run it locally. And we have all the files, and we like to grep things. So we'll do that. It goes through those. And it takes a couple of minutes, and eventually we will end up with 12,400 fresh parameters for us to fuss and send into the system. And also, hey, 58,000 endpoints that were inside the JavaScript files that we didn't know about, but maybe we want to poke at, because who knows what secrets can be behind those doors. I ask you again, but why more work? Because it puts the recon in the funnel, or it gets those again. Because we want to fuff that. Ding, bonus. Okay, you can also run a truffle hog on the local thing, and you can find keys that are in there. There were obviously no keys in there that I can show on the screen, but if you're getting the same recon data as I do, I think you will be able to find some cool stuff.
Oh, tiny STÖK, tiny STÖK. Do you remember that time when we wrote that bash liner that was the bash script that was like 60 lines long, and we were really proud of it, and it was a part of our automation. It got stuck, it just hanged up, and it was quite problematic for us. But it was a way for us to identify blind XXCs. And then you, Tiny STÖK, not me, Giant STÖK, came up with the idea that hey, maybe we should just do a Nuclei template on this. So from 60 lines of crappy code, we turned it to one YAML
Nuclei template. And Nuclei is a really cool way to, find stuff. I did this when I was doing this version of this talk for Detectify, and I wanted to be able to find like some stuff in their reports. So it's very, very simple to write, and it's very intuitive. It's just a YAML rule where you're sending what are you looking for, and whatever you get some data out. And Nuclei is very, very community driven, so there's so much things that are being sent in there and contributed all the time. So if you want to create like a vulnerability scanner and for your organization and get all the low-hanging fruit, if you run this and you don't get anything back, congrats, you did good. If you did get something back, it sucks being you, because then you got work to do. And this is continually being updated and contributed, and they're really, really, really fast on dropping these, because bug hunters going to bug hunt. And when the guys over at Asynode dropped their really nice cPanel CV here, just a day later, the Nuclei template was ready, and people just brrr all over the internet to see if they can find that. So, but that means that if you want to stand out of the game, you need to create your own custom Nuclei templates. And this is really good for that, because all hackers have their secret use, and they have some things that you like. So I would recommend you to dig into finding this, because it's a very, very easy way for you to find stuff and create, like, in this case, like I wanted to send this over all the addresses that was available on Detectify, and I wanted to look for if it contained bot history and scan information, and it was a 200. If that was true, then I wanted to get the results coming back. So I had about 7,000 lines, ran that over, and boom, some reports came out. And it got sent straight over to my Slack channel. I'm like, fuck yeah, good stuff. Automation is nice. This is slide 141. And this is where I tell you that I just wasted 30 minutes of your life, because you don't need to do any of the stuff that I did. All you need to do is run recon for the win. Because 6toDesk and the people over there, they're making this pretty fucking badass stuff. 6toDesk works for Visma, and they onboard a new company like every week, and their red team is continuously looking at these huge areas over the internet to make sure, if the risk is high enough for them to onboard the company. At least I think so. So this is a really cool way for you to do all the things that I did by just running one script. And it does this remarkably well, and it's always been updated. And whatever you want is going to, eventually end up in a nice HTML or CSV file, and you can get all this cool stuff looking at. And it comes with Axiom support. So you could, from your command line, select a target, automatically spin up 50, 100 Axiom instances, to go brrr, distribute it all over super fast, which means you're not going to get rate limited because you're changing the IPs all the time. And eventually, you'll have a lot of cool stuff. Fast, good. Axiom comes pre-populated with all the tools that I talked about. So if you want to do that, it's all set up in there. So you just clone it. And if you really want to take it to the next level, like now I'm talking next level shit, we can go serverless. And this is where Shadow Clone came in. Because you can do all the things that I told you, but you can distribute it at scale using Lambda or whatever. So in this case, we could scan like 94,000 subdomains using HTTPX in under 1 minute. That is maybe expensive, but it's also impressive. So If you liked any of the shit that I just talked about, you can find me on all socials at STÖK Frederick. If not, that's cool too. Thank you for joining my talk.
Nice. Couldn't ask for a better starter speaker on Friday.
No.
You're a shock of energy. It's so nice to listen to your talks. Do we have any questions for Frederick?
Yes, please.
Come on, don't be shy.
We got plenty of time.
You get a hug? No?
Can I get some music then?
Maybe some music.
Can I get some...
Will we be banned now?
So if 9:45 is too early for you to start drinking, welcome to Sweden.
That's good. That's
Okay,
good.
I'm out.
Yes, sir. So, yeah, take a short break, and then we will let you know when the next speaker is on.
Yay!
Have some coffee. Thank you so much again, Fredrik. I'm super happy to see that so many people are actually looking alive on Friday morning, which is epic. So without further ado, we will introduce our next speaker, which is Jonas. Take it away.
Thank you. So this is my first security fest, and it's really nice to be here. Awesome conference, awesome sponsors, and yeah, really happy so far. Also nice parties. I have kind of a jazz voice today, so I probably had fun. Right. Do have some slides. Nice. So my topic is Tales from the TEMP. But first, a few words about me. My name is Jonas Vestberg. I'm a senior security consultant at Center, and I've been there for the last 10 years. I'm a penetration tester. I do everything from web apps to Windows to AS400. So if you like AS400, please talk to me after. Nowadays, I try to focus mostly on Windows and Active Directory. And do some red teaming and try to pretend to be a developer, but mostly of offensive stuff. All right. A few words about Center. We're based in Sweden. I think most of you know who we are. We've been here for ages, survived the dot-com boom. We got acquired by Accenture a few years ago. We do, as most do, managed security services, InfoSec, and pen testing. And this handsome guy is in the audience. Oh, this happened again. Okay, cool. All right. So this talk is about the Windows temp directory, the scary place. I'm actually going to talk about a few vulnerabilities that I found, but I'm going to start off with a lame background. I feel obligated. I'm going to talk about how I found the vulnerabilities and how they can be exploited. And they're all privilege escalation vulnerabilities on Windows in third-party products. So just to get the right context, there are a few different execution modes on typical operating systems. You have user mode, you have kernel mode. If you're in a kernel, you basically control everything. But nowadays on Windows, you can't be there unless you're a sign driver, like cross-sign with Microsoft itself and everything. If you're in the user mode, you're either an application started by a standard user or a service. Services can run in different privileges. You can be an unprivileged service and a privileged service. The different kind of user privileges there are you can be standard user, you can be service, you can be an admin, or you can be a local system, which is the equivalent of root in Linux. Service is a little bit special. There are a few services that have documented escalation paths to system. So in general, if you can run code as a service, you can escalate to local system. And as an attacker, you're interested in these privileges because that will allow you to fully compromise the machine. And looking a bit about the attack surface, and now I'm talking about the attack surface from a local perspective. A local attacker is already on the system. You have like network sockets and all the different generic Windows objects that exist, like the file system, registry, RPC endpoints, name pipes, mail slots, everything. Most of these are controlled by access control lists. So you can set permissions on mostly everything, with the exception of network sockets, which is interesting, because then you only need to connect to a port. The assets that attackers are interested in is the integrity of the system itself, other systems running on other users logged in on the system. There might be a domain admin or a server admin logged in there. If you're able to compromise the machine, and then you can pivot in and use their privileges. The computer identity is interesting if you're in a domain joined environment. And there are also local secrets, like the local password hashes, service passwords, if you run a service as a domain user, for example, and also private keys for any certificates on there. So this is what the attacker would use a privilege escalation bug to obtain. If there are no interesting assets, then you can just use the privilege that you have as a foothold to attack other things on the network. Super basic privilege escalation is the act of exploiting a bug to gain elevated access, sometimes called elevation of privilege. I think that's Microsoft term if you look at security bulletins. There's a few different temp folders that used from different perspectives. Standard user have their temp folder under the app data. Services actually have a service profile located in the Windows directory. That's also on the app data. But if you run as local system, you have the ctemp. And that's kind of the temp directory that I'll be talking about for the rest of this presentation. Temp folders are interesting because normal folders, users can, if they have access, they can list files, they may be able to create files and subfolders. And if you are the owner of the object, like everywhere in the Windows and Active Directory, if you are the owner, you can, even if you don't have direct access, you can give yourself access. The temp directory is locked down. So standard users can't list files, but they can still create files, and they can create subfolders. And as owners, they have full permissions of the object that they create. So this is kind of how it looks. In this little screenshot, I'm a standard user trying to list ctemp, the Windows temp directory. This is the access control list. You can clearly see that the creator owner have full permissions that are inherited to subfolders. The users, the local users group, have write access that is also inherited. And then administrators and system have full permissions. So if you look to the right, you can see me as a standard user creating a test folder within the temp directory. I am the owner with full permissions, but users still have write access to create files and subfolders within that directory that I own. All right, so this is the tools that I've used. There's a few screenshots. I just want to mention them. Sysinternals have great tools for doing analysis of what processes do, what programs do on your system. Access check is if you want to, look at an ACL for a name pipe that I do in this case. It's useful, and I usually just use Visual Studio for creating apps and payloads and stuff. Right. So the first product I'm going to talk about is the Snow Inventory Agent for Windows. How many people have encountered this product before? There's a few hands. It's kind of what I expected. This is an inventory software that's made for enterprises. It scans local Windows systems to see what products are used and installed, and then sends that up to a server. It's developed in Sweden. It's like their office is like 400 meters away from where I live. It's quite common when we do pen tests, and the clients that we work with long term, they quite a lot are using this product. It used to have a third-party component that was used to kind of get the capabilities of the CPU. So this is what happens when an inventory scan is performed. It's triggered by a schedule. The service then continues to extract the DLL and then load that DLL. That DLL itself extracts the driver, loads the driver. The product does the thing and then unloads the driver, removes the driver, and same thing with the DLL. So this is how it looks in the process monitor when you do this the right way. After dropping that DLL, you can see that it checks for the driver. If it doesn't exist, it creates a folder, copies the driver, loads the driver, removes the driver, and removes the folder. So this is kind of a vulnerable behavior because you drop the driver on a static location. And it's a location where normal users can create files. So the attack is pretty neat. It's what you call bring your own vulnerable driver. You just drop a vulnerable driver instead of the intended driver. You have the service loaded for you, and then you just use a public exploit to escalate privileges. This is how it looks. I'm an unprivileged user. I have a very advanced APT batch script, which does all the magic. It just creates it copies the vulnerable driver. It then continues to remove privileges for the system identity, because we don't want it to overwrite a driver or remove it. And that kind of works. Then wait for the inventory to be triggered, which I'm doing in the background, just restarting the server. And then, on system. Thank you. So this is kind of what happened in more detail. Me as an unprivileged user, create a folder, copies the vulnerable driver, restrict permissions for system, wait for a scheduled inventory, and then use a copy-pasted exploit from Metasploit to do the hard work. Yeah, that's me coding, copy-paste on GitHub. All right, so this is how it looks in Process Monitor when the driver is already there. So the service is kind of lazy. It checks if the driver exists. Yeah, it exists, but it just continues anyway. It tries to create a folder. It's already there. Loads the driver. Then tries to remove the driver file, and fails. So it could be more picky, I think. So the timeline here is that I reported this through a friend that works there. He kind of speed-run the contact to one of the product security guys. I reported the vulnerability because this is in the third-party component CPU ID SDK. I reported to the developer, and they presented a fix shortly after that I verified. And then 3 years later, there was a security bulletin that sounded kind of familiar, so I had a look at it. And the same exploit just worked out of the box. So I was fairly certain that this was the exact same bug, but their product security team was like, "Oh, no, we found this in a private bug bounty. It's not the same bug." Okay, I'm actually not sure. It doesn't matter. Everything before version 6, 7, 8 is vulnerable. They remove this component from that version, and there's a workaround for anything before that. And I'm not super unhappy with this because we did a pen test around this time. So now that I knew that it worked on later versions, we were able to kind of abuse that to Privesc on some Citrix systems. It's always fun to use your own bug to do evil things. All right, so the next product I'm going to talk about is the F5 Big IP Edge client for Windows. And this is a VPN client software. And as VPN client softwares do, they install like 5 services that's running as a local system on your client. Those services do things like open the tunnel, do compliance checks, and of course you need something to install stuff, like an agent. I was helping a client out on a kind of a long-term gig. They were running this product on all their clients, and I read this security bulletin from another researcher, and I wanted to verify the fix. This was a vulnerability in the component installer service. That can be used to install MSI packages, EXEs, or CAB files. They do code signing checks, and they store stuff in the TEMP folder. the first thing we need to do to exploit or to kind of look at the behavior is find a way to trigger an installation. So I found this name pipe pretty early. It was fairly obvious that it was relevant. So I wrote a custom client for that, which probably took like half the research time because I was a terrible coder at that time. As you can see on the ACL, only system and administrators have access to talk to this pipe, but we also have the interactive identity. And this is given to all the applications started by an interactive session. So if you manage to exploit a service, for example, you won't be able to talk to this pipe. But if you're Notepad, you can talk to it. All right, they do code signing. They have authentic code signatures on all their components, and they only approve to install components signed by a short list of CAs, or actually short list of certificates that they have kind of bundled. I was able to bypass the code signature in this case simply by using DLL hijacking, because since all their own binaries are signed by them, I can trigger the installations of those programs. And this is how it looks. You can see the static path. I'm using an exe called cachecleaner.exe. And this is process monitor once again. You can see that it tries to load the DLL from the same directory. And this is kind of typical for DLL hijacking vulnerabilities. So this is me again. Very advanced bat file once again. I'm creating the static path, the F5 temp. I'm copying a DLL payload, which basically just runs netcat as a bind shell. I trigger an install with my custom client of the cache cleaner exe, and then just connect. It goes fast. Okay, so this is what happens in more detail. I, as an unprivileged user, create the temp folder once again, copies the payload to the cache cleaner DLL location, send the exe over the name pipe. The service will save that file in the temp folder, execute the cache cleaner.exe, though at the same time sideloading the cache cleaner DLL, and my payload is executed as system. So now I have verified the fixed vulnerability, and now I'm going to look at the next version where it's fixed. They didn't change anything, so I can use my custom client to send files to the service. And I noticed that there were a thread ID and a timestamp within the temporary path. So they tried to add some random data to it. And exe files were no longer supported. So to bypass this, it's not a super good solution because the thread ID is like kind of a global ID that you can query using Windows APIs. And the timestamp is just a timestamp. I can query that too. And CAB files are still supported. So this is kind of how the new temp directory looks. It looks scary at first, but then you kind of notice that there's no entropy in there. So to bypass this, we need to guess the temp folder. We need to bypass the code signatures for CAB files, and then we need to find a way to execute code using CAB files. So first, to guess the temp folder, we can use the Windows API create tool help snapshot. That's kind of the API that you use when you want to list processes and threads. There are multiple threads within the service process, so it's kind of challenging. To get the timestamp, this is the timestamp that the service uses. It's the get tick count, which is, I think it's millisecond precision from where the system was started. It's a bit of a delicate timing because you need to create, to exploit this, you need to create a bunch of folders. I'm going to get into that soon. But the positive thing is that we know when the file is created because we are the one triggering it, and we have basically unlimited attempts. So if we fail like the first 5 times, we can continue. Right. So first we list the thread IDs of the service process. Then we select one of the threads. Usually the second thread is the one that's used by the installer. We call the tick count, and then we add a small offset because we want to pre-create all the folders so that we can win this race. Then we trigger a installation through the name pipe, and then just hope for the best. So I try to visualize kind of how the attack works. My exploit tries to create all the different folders with different timestamps for a certain thread ID, and then just based on timing, the service will hit one of those folders, and we win our race. And this is how it looks in Process Monitor when I win my race. As you can see here, is a name collision, which means that, or I'm gonna bring my laser pointer. Here we see a name collision, and that means that the folder already exists, and I was the one that created it. And this is my custom client that continues to create folders, actually symlinks, but basically folders, right? Then the next step is to bypass the code signatures, because now we won the race, but we still need to send something there that they will trigger an installation of. So when I looked at the behavior, I could see that it began with writing the file to the temp folder, and then it, in a number of steps, verified the code signature, and then finally it began to install the cab file. So what we need to do is still guess the temp folder, and then just present a signed cab for the check, and then at the last step, just switch in an unsigned cab. To continue to explain this attack, we need to go through some basics. So there's something called oplocks, which is opportunistic locks. This means that you can create a lock for a certain file operation on a file, which blocks execution for other threads trying to read that file. And if we created that lock, we can also release the lock, which makes it possible for us to control the timing. And this can be done using a proof of concept tool from Google Project Zero. And this is how it looks in the most kind of basic situation. We have a file. I can create an oplock on that file just to show that how execution is stalled when another thread is trying to open that. Then I go back to the first console window and release the lock. So this is great when you're trying to exploit timing vulnerabilities. And there's also something called symlinks, and this is like super duper basic if you're used to Linux. But symlinks, yeah, it's a reference, it's a weak reference to a file. The file does not have to exist, it's just a loose reference. Symlinks do exist in the NTFS file system, but on Windows, you can't create symlinks unless you have admin privileges by default. But there are certain technique that can be used to create something that is the equivalent of symlinks. Using directory junctions, which is basically the same thing as a symlink, but only for directories. And then you have a link in the object manager that will then later reference a file. So you basically create a junction pointing that to a certain category in the object manager, and then within the object manager you have a link to the file. This does not require admin privileges, but it has a few other requirements. And there's also a proof of concept from the same Google Zero project. This is how a junction looks like when you create it. It's actually kind of like a folder which references RPC control, and that's a kind of a category or a type within the object manager here. And here I created a symlink within the object manager that references a file on another location. Right, so this is an example of using that to create a symlink. I create a junction called test files and a symlink called test.txt. And I reference that to a file in a non-existing file in the system32 directory. And below is an administrator that writes to the file or to the symlink, just showing that that data will eventually end up in system32. And this is a kind of a great exploit primitive when you're looking at logic bugs on Windows. And I'm a slow typer, sorry about that. Yeah. All right. So, where were we? We wanted to kind of switcheroo in the unsigned cab at the last step. And this is, once again, process monitor showing that the service writes the file and then it checks signature a few times, and then on the last step it kind of parses the cab file contents and extracts it. And this is actually a timer check, timer use vulnerability, a timing vulnerability that you can exploit using oplocks. You send an oplock on a file. In this case, you have like two separate read operations that are not within a transaction. So you set an oplock on a file, you wait for the victim to hit that lock, then you release the lock, and then you switch to the bad file, and the next, when the file is actually used, you have your bad file or the bad contents in that file. But the problem is here that I have a queue of read operations, and oplocks in its basic form can't be queued. So if I have an oplock and two different threads are reading it, they both will be kind of released, or the execution for both threads will be continued when I release the lock. So I had to find a way to get around this. So I managed to kind of use symlinks to queue oplocks. So I create multiple files, I create oplocks on those files, and then I create a symlink that the kind of victim or targeted process will try to access. And then as soon as the first read operation continues, I release the lock and switch the symlink to the next file descriptor with a new lock, and then I release the lock on the second read, pass it on to the next, and on the last step, we have a clean read on the modified or the bad file. And in the example of the cab file, the actual cab was parsed on the read operation number 7. Okay, so now that we were able to bypass the code signatures, we need to still find a way to execute code using cab files. And cab files are interesting because they have a rich feature set. If you're old like me, you remember the ActiveX controls that you kind of installed through the browser in Internet Explorer ages ago. So a lot of the features were used in that scenario. You have an in file within the cab file. Cab is a file archive, first of all. And the in file kind of works as a manifest. It defines what ActiveX objects to kind of register, or what services to install, and what files are in there. So the easiest way I found, using internet archaeologist, I kind of found the documentation to set up hooks within the in file that just simply ran a command. And there are also the possibility to kind of exploit the fact that the cab file is extracted, so you can kind of switch in a DLL that you want to the service to parse at a later stage. So that's another type of race condition, but it was a bit more tricky to exploit. So I'm going to use this case. I have a simple cab file with netcat, and in the in file defines a setup hook that just uses netcat as a bind shell, and yeah, I craft that in file, add the netcat exe, and just make a cab from that contents. Okay, now we have everything we need to exploit this bug. So this is how it looks. It's a bit more tricky. In the bottom console window, we have the custom bait and switch. That's going to switch in the backdoored file on the read number 7. Yeah, I like my script files. I have a client that designed to win the race, so that will create like 1,000 folders that reference or represent the different timestamps in the future. So once I then trigger the installation, it wins the race and loads that cab file. Yeah, and it repeats. So thanks. Right. So they made a fix when I reported this. They had a random token within the folder, but they moved the folder to program data, which is just made it worse. Because program data is just an ordinary folder that inherits all the ACLs from TEMP or the roots, I think. So this took about 20 minutes to bypass. You just monitor files within the program data folder. When that directory shows up, you just put your DLL there and wait for the service to load it. So that was disappointing. Yeah, I don't think I even needed to use an oplock, but yeah. And they produced another fix, which actually used the same random token, but they moved it back to CTEMP, and that's sufficient. So they got the green light. At that point, they already released the even worse version, but they didn't present any security bulletin. So this is kind of how I reported this. I found this in 2020, late in 2020. I reported it to the F5 CERT. I got a pre-release like 5 months after, which made it worse, which I reported a few days after. That still got released, but the security bulletin didn't. That's one way of doing it, I guess. And then a few weeks after, they released the .3 version. I retested it, and it was good. And the component installation service got a CV for the temp folder failure. I actually got a CV for the for the DLL hijacking, which is really weird because I think most their binaries can be used to do the same. But yes, okay. And even though they fixed it in the new version, an attacker would still be able to use the old versions because it's still signed. Okay, so they have a few different kind of version tracks, but it was fixed in 7212, or everything up to 7212 is vulnerable. All right, how are we on time? I think we're good. There's not a scientific results from this, but there's a few lessons learned regarding attack surface. Everything you add or everything you install on a system is an additional attack surface, especially when it's services running with high privileges. And enterprise software is typically, or enterprise products is typically something that they like the agents and the services. If you look at a typical enterprise client running on a fairly large organization, you probably see like 1 or 2 security softwares and an inventory agent and like backup software, and yeah, there's a lot of attack surface. And just because it's enterprise software doesn't mean that they actually looked at the security of the product. And I think if you look at like CV history, you'll notice that every single update service has been vulnerable to something like this at one point in time. I think that's a kind of almost a rule. Product security is hard. If you look at these 2 cases, both vendors actually failed to fix the bug that I reported. yeah, they did have good security people, and I actually don't know what the hell went wrong. I think it's something within the versioning of releases. I think they just maybe one release was actually fixed, and then the next they just used an old version of the vulnerable component. But it's kind of depressing. As a developer, you need to know your own platform. You need to know all these quirks and weird things, like the temp directory. And of course, it's important to verify fixes. Even if it's an easy fix, it's really hard, or it's really easy for developers to miss tiny details. If you're a security consultant that reports bugs and do retesting, you, of course, know this already. All right, so I totally lost control of time, but I have some extra material that we can run if we have time. Sure. My PowerPoint skills have improved. All right, so I did a presentation at Disobey earlier this year when I talked about finding vulnerabilities in offensive tooling. I looked at a number of example scripts in Packet, and I thought one of these is kind of fits the theme, because they also fail in how they use the temp directory. So this is the SMB exec. If you don't know, in Packet, it's a kind of a offensive tool set written in Python that interacts with, or they implement a number of Windows protocols from scratch. It's kind of impressive if you look back, because at the time where the project started, I don't think there were any third-party implementations of some of the RPC stuff that they implemented. But SMB exec is used for lateral movement. It's really a super duper basic script. It's used to execute code as system. It's easy because they don't deploy any agent on the target. Just create a new service, and then kind of writes a command line to the bin path of the service, and then executes that. And it happens that that command line use a static path to a script file located in the temp directory, and then it executes that and removes it. And then it writes the output to __output within the C directory. It's kind of fun if you're a blue teamer, because if you can control the contents on that file, you can kind of troll pen testers by writing fake output. Okay, so I'm not sure if this is visible, but to the left you have like an attacker or a pen tester or whatever. To the right you have me running a tool as a non-previous user. I use that to start Notepad as system. And I think you can see from the kind of comments that I create the execute script within the ctemp as a non-previous user. I'm the owner of that file. I create an oplock on the execute BAT. When the oplock is released, that's the time where SMB exec writes the command to that file. But since I'm the owner, I can then just replace that with my payload, and then the next step, the service will execute that file with my payload as a system. And the solution here is to, well, don't put your payloads in where unprevious user, or the fix is that you should write the file somewhere that normal users can't change the contents. And it seems appropriate to use a random name as well. This was fixed in Packet earlier this year. This is how the vulnerable version looks like if you look at it in Process Monitor. And this is how the fixed version looks like. Every command will be executed in a separate file. Right, that's it. Thank you.
Thank you so much. Do we have any questions? Anyone? Any questions? Everyone is very shy today. I don't know why.
think we have one there.
I think we have one over here.
One over here. Go. Go.
Hi.
Hi.
Thanks for the talk. I wanted to ask you about when you gave the information to the team to fix the temp and then they replaced it with program data.
Yeah.
Did they have all the context to know why that's a bad thing, or?
I mean, I didn't. My recommendation were to move it to the service profile under System 32. That's a directory where standard users can't create files or even read files. They obviously didn't listen, and they put it in program data instead. So I have no idea what happened. It took like 5 months, so it wasn't like we had daily contact either.
Okay, anyone else?
No?
It's fairly common that applications use program data for temporary files, and that's okay as long as you know, when you deploy the application, create a folder and restrict access to system, basically. And that's typically what you see.
Thank you so much.
Right. Thanks.
So, before we let you go, you met me, and you met Johan, of course.
Yo.
And it would be awesome if we were able to do this alone, but we don't. We have a whole team.
That would be impossible.
Yeah, and they are not really shown that much. So I think we should bring them on stage. So could we give some, could all the goons and everyone get up here? The superheroes of Security Fest. Come on, guys. Woohoo!
We can barely fit everyone on stage.
Here they are, all of them.
Oh, right. We've grown a lot, but it's so good to have all these amazing people running this conference with us. We couldn't do it without you guys.
Nope, that's true. We've grown a lot since we first started. That's all thanks to you guys.
Yeah. So we have a few talks left, and we have lunch and a lot of other fun things still to do. But while we have everyone here, and you guys are still in the audience, thank you so much for Security Fest this year. All right.
And now go help yourself with some coffee and drinks and whatnot, and we will start the next speaker according to the schedule. Peace. A little bit more volume, maybe. There we go. Okay, so find your seats. Time to introduce the next speakers. Are you guys ready? These are old colleagues, one of them. Pretty cool, eh? Back in the before days. It's cool. Okay, find your seats. Get in here. You don't want to miss this. Come on. Run. Okay, so it's time. We have Tobias and Pontus from Omega Point. They're going to do a really interesting presentation about OAuth, I think, and how to do it or not. So help me with a warm welcome for these two gentlemen.
Okay, so thank you for the introduction and welcome everyone.
Yeah, my name is Pontus and I work as a security researcher and penetration tester at Omega Point, and I spend my days hacking systems and devices. And with me I have my colleague.
Yeah, Tobias, and I like to build secure applications and we work at Omega Point Gothenburg doing penetration testing and security reviews. And together we have a lot of experience both building and attacking OAuth 2 and OpenID Connect implementations.
And today we will show a few things that can go bad in OAuth 2 based implementations, even if you follow security recommendations and best current practices. And I just want to point out, if you're not following best current practices, you might have a lot worse problems than the ones we'll discuss today. So for this talk, we assume that you've done your work and done your homework as developers and architects and invested in a secure implementation.
Yeah, so maybe a little strong language there in the title, but it's kind of how it feels like when you realize you have a much weaker solution than you expect. And we hope that with this presentation, if you're like Pontus here on the offensive side, that you will get a better understanding on how OAuth is built these days. And if you're more like me on the defensive side, you will get a better understanding on the attacks and challenges we are facing as developers and architects. And in particular, we will highlight some pitfalls and weaknesses connected to the OAuth 2 backend for frontend pattern. But first, we will do a little bit of history around OAuth 2 and how we do secure implementations in 2023. And yeah, many of you might know the story and how OAuth has evolved. Over the years, there's been a lot of weak sort of custom flavored so-called OAuth login implementations, and big companies like Microsoft, Apple, Facebook have all done mistakes here. And to address these issues, there has been security profiles introduced, and one is FAPI, the financial grade for OpenID Connect. Even if it's called financial, it still applies to healthcare and other domains which has high security requirements. And then we also have the current best practices, or BCPs for short, and they are gathered in OAuth 2.1.
And there's a ton of specs online and good online reading materials, but covering all the flows usually requires about a 2-day workshop, and we don't have time for that today. But I really do recommend reading the 2.1 and FAPI specifications. They're quite easy to understand and digest compared to the core OAuth 2 specification.
Yeah, and two things to note there to avoid some confusion maybe is that the BCPs in this presentation, it's best current practices for OAuth 2, not the business continuity plans if you're sort of from the InfoSec community. And sometimes we just say OAuth, and by that we mean OAuth 2, not OAuth 1. And so to summarize all this, it has matured, and many system builds today use OAuth in some way. And the community around OAuth and OpenID Connect knows how to do this securely, even for systems in domains with high security requirements, like finance and healthcare. And just so you don't fall asleep while we talk about the specs here, we will give you a 2-minute version of the specs and to highlight a few things that are important for this presentation. And yeah, here it is, so pay attention. When we do system integrations and no humans are involved, system to system, we use OAuth 2 client credentials. And to strengthen that, to sort of be FAPI compliant and get this financial grade security, we should also use strong client authentication together with sender constrained access tokens. And we do that using mutual TLS, or if we don't like the public key infrastructure things, we can use a new thing called Depop. But both of them are just asymmetric crypto with the private public key pair for each client. So there's not that big of a difference. And we should always use short-lived access tokens. And if we have a third-party client, we should consider using something called reference tokens.
Yeah, and when we have a user with a web browser involved, the main flow is OAuth 2 code grant with Pixie. But if you, and to get user consent and delegate authorization to user resources. If you also need login, session, and identity, the recommendation is to use OpenID code flow, which is an identity layer built on top of OAuth 2. These implementations can also be strengthened, just like the client credentials case, with strong client authentication and sender-constrained access tokens. For web applications, you should not have tokens in your JavaScript frontend, but instead opt for a backend for frontend component, which is a confidential OAuth 2 client. And for financial grade APIs, you can also use a new thing called pushed authorization requests.
Yeah, so this sounds, well, maybe not easy, but at least it's well-defined or well-known, and you can read about all this online, of course. We will not explain the concepts in this presentation. So, if you've done all this, is the problem solved then?
Well, I wish I could say that, but in our experience reviewing and performing penetration tests of systems implementing OAuth, we can say that most of them do not follow the best current practices, or they follow best current practices that are no longer current. So the C in best current practice stands for current, and that's subject to change. So a lot of what we see today are systems still handling tokens in the front end. A lot of token services don't yet support pushed authorization requests, and the specification for PAR will most likely be finalized this year. So with that, we hope that adoption can increase. We also often encounter organizations that still use basic client authentication and bearer tokens, and that means that they're not able to do sender constrained tokens.
Yeah, so security misconfiguration and insecure design are on the OWASP top 10 list for a reason. And but we should note that not all systems need to be financial grade, so it always depends on your sort of threat model and business. But the backend for front-end pattern is for everyone, but maybe not doing mutual TLS and sender constrained access tokens or PAR. So that's important to keep in mind. But let's say you have done your homework, you've done all this that we talked about. Are you secure then?
Well, to answer that, we'll take a time machine and look back at a system implemented according to the best current practices of 2019, somewhere around that. And to be clear, this is what we, as me and Tobias, and the security community as a whole, recommended 4 years ago to our clients.
Yes, so that means that there was a lot of clients built this way, of course. And so, remember 2019, before the pandemic, what did we do back then?
Apparently it was the best year ever, at least according to New York Times. But I wonder if that also covers OAuth 2 best practices.
Yeah, so who hasn't updated their design and implementation since then? I mean, it's 8 years ago. So it's time for a demo, and we start with a little bit of context. And this is what the 2019 best current practices implementation would look like. And we have a token service, and Then we have the APIs, and in a real-world scenario, we would maybe have 10 or hundreds of backend APIs here, but we have 2 to just represent that there are more than one. And the access model for the API here is that the low-privileged logged-in user should be able to get products and get their own orders, but not any other customers' orders. And they should definitely not be able to get all orders using the get all orders endpoint, which is meant for the order processor, a system integration. So keep that access model in your mind when we look at the demo later. And then we have the SPA, where the user logs in. It is all happening in the browser, so it's a standalone JavaScript client, which means that it's a public OAuth client with no client secret, because JavaScript can't keep secrets, so you can't use that. And that is doing all this OpenID Connect code flow with Pixie in the browsers, and there are, of course, a lot of arrows going back and forth between the browser and the token service. But we represent it with just one arrow here, and it's the get token request to make it clear that it is the browser and the JavaScript frontend that handles the token. So the request is there. And it's very common for those kind of frameworks to store the token in local storage. You could, of course, handle it in other ways, but that's a common practice. And also, one thing here is that in order to tokens are short-lived, but the user might need a long-lived session and can't be bothered to log in every now and then. So this means that you need to refresh that token. And the refresh token flow should not be used in public clients. So the security recommendations of 2019 is to use something called silent renew. And we will look into that a little bit more later. So that was the context. And the attack here is that the attacker wants to get all orders, and for that the attacker needs a valid token and be able to call the get all orders endpoint. So now, Pontus, let's see if you can steal some tokens from this SPA that I've built.
Yeah, let's have a look at that. I'll switch over to my browser, and next to it I have burpsuit. I'll use that so that we can look at the network traffic between my browser and the single page application and the APIs. So first I'll just load up the application. To start using it, I first need to log in. Otherwise, I can't get access to any of the features. So I press the login button here, and I get redirected to the identity server.
Yeah, and maybe you're familiar with this, but this is the Duend identity server we use here. We just want to point out that this talk is not about any specific product or framework. We talk about general design weaknesses and pitfall valid for any OAuth implementation. So there you could use many other products as a token service, of course.
And if I log in with my credentials here, press enter, I'm redirected back to the single page application. And there's a lot happening here. So if we scroll back a little bit in the network history, we post our credentials to the token service. We get redirected back to the single page application with a code. Now this code doesn't do us any good. We can't use that to access APIs. So what happens next is now we exchange that code for an access token. So we send the code back to the IDP, and we get back an access token. Now that we're signed in, we can call any APIs. We have a get orders, get my orders, get my Swedish order, and I can also do product search by ID. We can look at the API requests here, and we can see that there's an access token attached to those requests.
Yeah, and we can also note that the API calls are directly to the backend APIs hosts.
Exactly. And so you asked me if I can steal a token. And one way of stealing a token is if I can find a cross-site scripting vulnerability so that I can execute arbitrary JavaScript under context of this origin and the victims session. And fortunately for me, this application is super vulnerable through the search field here. So it renders anything I put in here. For example, I can put a U tag, and you can see it renders as underscore here. So what I want to do now, in this application, I could just go into local storage and fetch the access token because it's in there. Sometimes developers try to hide that code or just keep it in memory, so that might be it might be harder to figure out where it is. So what I'll use instead is to leverage the silent renew flow. And we have really short-lived access tokens for this application. And you can see, if you paid attention to the burp window here, that there's a lot of things happening. And so there is a silent refresh flow happening. And we can look at the, let's see if we can find the authorization request here. Here it is. So this, what silent refresh is that the application opens a hidden iframe, which loads the authorization request to the IDP, which has the single sign-on cookie already. The single sign-on cookie gets attached to the request, and we get back a new code and can do the whole exchange process again. And since I can now execute arbitrary JavaScript on the context of a client, I can do the same thing basically. So what I've set up for this demo is an attacker server that hosts a JavaScript payload that will do exactly that: create an iframe, get the code, and then send that code back to the attacker server and exchange that for a token. So I'll just copy this payload, paste that here, and it all happened quite fast. But what happened on the attacker server, we received a code which was then exchanged for an access token, and I can now use that access token to call the APIs on behalf of the user that I attacked. And this is one of the reasons why we no longer recommend using access tokens in the JavaScript frontend.
Yeah, so what Pontus just showed there is that we can't really hide tokens if the attacker can run code in your application. If you want to look more on this subject, there was a great presentation from Philip Derick from NDC Security earlier this year. But now, how can we fix this? If we instead follow the best current practice of today, and the most obvious thing here is, of course, to move things to the back end. Here we have refactored to from the 2019 SPA to a backend for front-end design. And the SPA is almost exactly the same, with one big difference here is that it's now served from the backend for front-end, which is a backend component. And all openly connect stuff, all that complex JavaScript code has now been thrown away, and everything has moved to the backend. So as you can see here, the token request now is from the backend to the token service. So there are no tokens in the front end anymore going through the browser, which is good. And now we protect the session to the backend for front end with a classic secure cookie session, and that really is secure. I'm not joking. so there's no issues there. And yeah, and then to make it even harder, so now you have no tokens in the front end, which you can steal. And to make this even harder, we have also followed the best practices with using a gateway or firewall or something. We heard a good talk yesterday and about not exposing things on the internet if they're not supposed to do that. So we do this properly now. And so now the backend APIs, they are not even exposed to the internet anymore. The only thing there is the backend for frontend. So now, Pontus, I dare you. Try and steal tokens. No, I double dare you.
Let's go back to our browser. I'll first log out here and load up the 2023 single page application. I'll just clear my history here so you can see the new things. Again, I need to first log in. I'm redirected to the IDP. Sign in as Alice again. This time around, we still get a code back when we are redirected back to the application. However, there's no token exchange happening between my browser and the backend or the token. And when I do API requests like this, we can see them here. there is no token in these requests. However, there is the session token that Tobias mentioned.
And all the request goes to the backend for frontend, not to the API hosts. That's
exactly. And this token is marked as HTTP only, meaning that even if I have an XSS vulnerability in this application, I cannot access that token. If I do document.cookie, it's
cookie.
So the cookie is not available to JavaScript. So even I do document.cookie, I get an empty string back. And we can try. I mean, you saw that we do get the code, so we can try to exploit the same kind of vulnerability we did the last time. Doing that, copying this payload, just entering it here. We do get the code, but when we try to exchange that for the access token, we get an invalid client error. And if we look at the error message from the IDP, which happened to be in the window above here, we see that the client secret validation failed for this client. And that's because I simply don't have that client secret.
So that's the strength of having confidential clients, which do client authentication.
Yeah. And so now I'm not able to steal an access token, which is really good. However, since we're still vulnerable to cross-site scripting, I can still do what's called session writing. I mean, performing requests just like the user's browser would do through the user's browser. I mean, however, that's sort of a more constrained type of attack, and as soon as the victim user navigates to another origin or closes the tab, I'm out. I can do anything. So that heavily limits both the time and the opportunity that I had to actually do anything.
So even if we use this pattern, we must still protect against the cross-site scripting, because that can be really bad for us. And but we have this third endpoint, the get all orders endpoint, which you should not be able to use from this user session, even if you can sort of do session writing. So let us see if you can do that.
Exactly. Let's try again. If we look at the requests towards the BFF here, we can see that they go to orders, API orders. So that's them hitting the BFF and them getting redirected. By repeating that request and modifying the request URL, I'll just add /all here and send that, and boom, I get all orders.
Not good. All our defenses. I mean, how was this possible? We had the firewall and everything, and the backend for front end, and you didn't even have to steal a token for this, to reaching this more high privileged endpoint. And you bypassed all our defenses by just changing the router. And to analyze this, we go back to the system design and back to the slides. And so if we follow the best current practice of today, this is what we get. And as I said, all compliance checkboxes, they are green, and we have a solid, secure design. But the negative test case, the user should not be able to access system integration APIs, like the get all orders API. It fails. So why is that? What enabled Pontus to do this attack? And if we take a closer look and start looking at the routing here, which seems to be an issue, a common default way to configure reverse proxies and like the backend for frontend here is to do like this. And it looks, so what, if we look at this, it's just conceptual sort of configuration. So what's the issue here?
Yeah, if we look at the match and path statements here, you can see the *any. That acts as sort of a catch-all routing, meaning that all requests towards the orders API get forwarded through the backend for frontend, even towards the sensitive endpoints such as the get all orders, which should not be accessible for normal users, and especially not for attackers.
So it's of course great for the sort of developer experience and availability to make things work out of the box. But if you think of confidentiality and integrity, it's not that good, because it's hard to keep control over which endpoint you can reach with this star pattern. And so if we go back to the system overview and we look at the backend for front-end design. The backend for front-end's job is to proxy request, and it's quite common for an API host or a microservice to have endpoints for both users and admins and system integrations all in the same host. So even if the proxy that we looked at had an allow list for which host they can route to, that may not provide any protection, because if you're on the same host, then you will get there anyway. But I mean, it's still just APIs, and back in 2019, they were all public. So what's the problem?
Yeah, well, the BFF, backend for frontend, has really two responsibilities. Besides just routing and acting as a reverse proxy, it also attaches the user's access token to all requests.
Yeah, and so once again, why is that so bad? I mean, as long as the API does proper access control, it shouldn't be an issue. So the question is, does your average API do proper access control?
Unfortunately not. I mean, at least in my experience doing penetration tests of APIs, we almost always see improper access control or authorization. And the OWASP top 10 list shows the same thing, with number 1, 2, and 5 all being about authentication, authorization, or access control in some way.
Yeah, and in this backend for frontend scenario, it's also quite hard for APIs to do this right, because it could be a quite powerful token that gets attached to every request, having sort of the scope for all API hosts or a part of it. So it's not that easy to get it right if you just base it on scopes and tokens. And so besides the access control here, there are other things to consider as well. For this attack to be successful, we actually need 4 things to be present at the same time.
Yeah, and the first thing is that we need a valid session, and getting that as an attacker can be super simple. If the system has public sign-up, you can just register an account, and other ways there are all sorts of ways of getting access to an account and a session. For one thing, phishing credentials is a problem for any large organization, and as the old saying goes, hackers don't break in, they log in. We also often encounter backend for front-end components that have unfeathered access to internal networks. I mean, who does network segmentation in the cloud? We also very commonly come across this type of catch-all routing that just forwards any request using wildcards to internal services. And finally, in every system with large enough complexity, we find access control bugs.
Yeah, so it might seem unlikely that all these things happening at the same time, but it really isn't. So it's definitely worth considering as a risk. And before we'll look closer on this, we want to point out that if you're not following the best current practices, you might have much worse issues than this that we are talking about right now. And so how can we do mitigations to lower the risk of this?
Yeah.
And as always, sort of this sound security design principle will help us and guide us. And we have the zero trust and least privilege for the API here that tells us that we must do proper access control regardless of any infrastructure protection. But we should also build defenses in multiple layers, defense in depth, so we should also have a firewall or a gateway of some sort in front of us, giving us some basic protection. How to build secure APIs, it's a talk of its own, and we just want to highlight one thing. Be careful and do not base admin or system integration API access on just a valid token and scopes. Use something more like maybe client ID, grant, or authentication method, because scopes they sort of tend to give more permissions over time, especially in larger organizations. And infrastructure and network layer security is also out of scope for this presentation, but we should note that we should use this, of course, and we should not expose internal APIs to the internet just because the cloud makes it so easy for us. So proper network segmentation is important for defense in depth. And we could solve this problem introducing more hosts and doing proper network segmentation, of course, but it might not be possible for us. And given defense in depth, we shouldn't rely on that. So we should have multiple layers of defense anyway. And so we will look more closely to the routing here and see what can we do to strengthen this.
Yeah, and the solution is quite easy. It's about specifying the exact method and path used for all endpoints that should be reachable through the backend for frontend. Now, this is super easy to do, but it might be a little bit tedious when you have a system with more API endpoints than just these two. But I really do encourage you not to try to be clever here and fall back to wildcards, because they will bite you in the ass eventually.
Yeah. So with this change, we get the following overview.
Yeah, and now we only have the specified endpoints with the exact method and path match. So we can only actually reach the get product by ID and get my orders endpoints through the backend for frontend. There is no way to access the get all orders endpoint through the backend from frontend with the user's session.
So with this, we have shown how to build a secure OAuth 2 or OpenID Connect implementation following the best current practices of today, and how to avoid common pitfalls and design weaknesses. So this time, the good guys win. And it's time for us to summarize.
Yes, so this is sort of how to not fuck up at OAuth while following the best current practices.
Yeah, and the first thing we want to point out is that please read and follow the best current practices. It's just as simple as that. It's good guidance, and they are actionable and also easier to understand than the original core specs of OAuth.
Yeah, and then we want to point out to stop handling access tokens in JavaScript frontends. They cannot keep secrets. Instead, start using the backend for frontend pattern with a confidential OAuth 2 client, and use a strict allow list. Don't let your backend for frontend be a vector for authenticated service-side request forgery. And as always, implement proper access control in your APIs, and implement proper out-to-put encoding and put other types of defenses so that you're not vulnerable to cross-site scripting, and do other types of application security defenses.
Yeah, that was it. And if you want to know more about this and application security topics, we have written about it at our blog there at securityblog, omegapoint.se. Yeah, any questions?
Any questions from anyone? Yes, in the, where? Over here, okay. Let's see, who was it? There we go.
Good presentation. How will you handle long-lived sessions then?
Yes, so the long-lived session, the backend for frontend, it will also get an access token and a refresh token. So that's the refresh token flow. So let's say you have an access token that maybe you have lives in 5 minutes, and then you have a refresh token which you can use for an hour maybe, and then do re-authentication. So that's so you need to keep that in sync with the cookie session that you have. So that's also need to have its max length and its sliding sort of inactivity timeout. It could be a presentation of its own, but then you also need to make sure that that is in sync with the single sign-on session to the identity server as well. So it gets a little bit complex there, but
yeah, and just redirecting the user back to the IDP with an authorization request, that for the user it just sort of happens very quickly and just blinks for them, so that can happen quite easily.
But it's interesting. So it's very good to test that logout actually works, that the session really ends, because it's quite hard. It's easy to do single sign-on, but it's hard to do single logout. Yep.
All right, do we have any more questions? No? All right, thanks so much, guys.
Okay, thank you.
And as you may have noted by the schedule, it's time for lunch once again. And it's the same deal as yesterday. So go outside, go around, go into the dining hall, sit down, and someone will bring you food. And we'll see you back here in about an hour. All right, everybody. Thanks for coming back and joining us for the second to last talk. And without further ado, please join me in welcoming Sriraam, Natarajan, and Venkatraman Kumar.
Thank you. Good afternoon, guys. Hope you had a great lunch. So, talk titled Beyond On-Premises will be walking you through the techniques and exploitation path for laterally moving from the on-premises Active Directory to the cloud. So, who are we? My colleague Venkatraman goes by the handle Red Wolf. He's also the chapter lead at WASP Chennai, and I am Sriraam, goes by the handle Vato. We are from India. We work as security analysts at Securin, a global leader in attack surface management and vulnerability intelligence. We have a couple of certifications like CRTP and CRTE. We love doing red teaming exercises, Hack the Box Pro Labs, and CTFs. We are actively researching on Active Directory attacks, adversary simulations, and various other EDR evasion techniques. You can check out our blogs at hackersprint.com. Agenda for this talk would be how and why we need to move into Azure. Then we will talk about the introduction about Azure Active Directory and hybrid identity and authentication methods. Then we will move on to the enumeration of Azure tenant and the privilege escalation and exploitation path for those authentication methods. Finally, we will be discussing about bypassing the controls and mitigation strategies. Then we will touch upon our future work too, unveiling the unexpected twist. So during our pen test engagements, we delved into privilege escalation phase, and we noticed similar patterns across all our engagements. Notably, we observed that account with naming convention of MSOL followed by some hex had replicating directory changes and replicating directory changes all privileges over the domain. So with this, we could we were able to easily compromise the domain since we could do a DC sync attack. But the outcome turned out to be quite opposite, leading us to an unexpected path. As you can see, the MSOL account had get changes and get changes all privileges over the domain, with which you could do a DC sync attack. And it also had generic write privileges over the domain admin, so you could add yourselves to the domain admins group. This was taken from a real-world engagement. And we dumped the MSOL account's password, and we used that to authenticate. And we are able to dump the NTDS hashes from the domain controller. Why we need to move into cloud? Basically, organizations store lots of juicy informations like their financial data, their employees' PII, and a lot of data. And so if you have more data, then it will be more fun. Also, Microsoft provides native support for Azure Active Directory with on-premises Active Directory, and quite increase in, we could see quite increase in organizations using Azure AD as a hybrid environment. Also, we could see an exponential growth in attack surface, since if you compromise a single root tenant, you could easily compromise all the domains that are present under that single root tenant. What is Azure Active Directory? It is basically a cloud-based identity and access management service. The differences between on-premises AD and Azure AD is, in on-premises AD, you follow a domain or forest structure, whereas in Azure AD, you follow a tenant. For authentication purposes, you use NTLM and Kerberos authentication on on-premises AD, and Azure AD use OAuth, SAML, and OpenID. In on-premises AD, you have organizational units and GPOs, whereas you don't have those on the Azure AD. For querying the domain, you use LDAP, and on Azure AD, you use APIs. Let's see what is hybrid identity. So Azure Active Directory creates a standard user identity for authentication or authorization purpose to access all the resources that are present on both Active Directory on-premises and cloud. This simply means the user could access cloud and on-premises resource with a single authentication material, eliminating the need for any additional authentication material. To achieve this, there are 3 authentication methods: password asynchronization, pass-through authentication, and ADFS. As the name suggests, password asynchronization is used to synchronize the passwords from on-premises AD and the Azure AD. Pass-through authentication, in pass-through authentication, user sign-in is sent over to the on-premises AD for validation, whereas in ADFS, it is based on a third-party entity, which is usually a federated server, and the authentication takes place as a certificate-based authentication mechanism. Now we will see the enumeration of Azure tenant from an unauthenticated perspective to easily identify if organization uses Azure services or not is by just simply logging in with their user email on login.microsoftonline.com. If you are taken to the password page, then you can assume that the organization is using Azure services. Otherwise, they are not. Also, you could gather lots of information like tenant ID by getting a get request to the following endpoint. We here use a tool called AAD internals, which is the most common arsenal for PowerShell modules. It is used for administrating Azure AD and Office 365. You could manually import it to the PowerShell, or you could just install it directly from the NuGet packages. With this tool, we can enumerate lot of information like tenant name, authentication type they are using, the brand name they are using. You could also get all the domains that are present in a single root tenant, so that you can see what are the domains that are associated with the single root tenant. Azure services are specific, like are available on specific domains and subdomains. We can enumerate the Azure services used by those organizations by looking for those subdomains. There is a tool called Microbust that can help us in enumerating those subdomains, looking for Azure services. Now let's move on to the authenticated enumeration. So if you have a low-level user of username and password, you can just use that to create a credential blob and a request access token. With this low-level user, you could gain lots of information like sync service configuration. Basically, it tells us where the sync service is running on the on-premises network. You could also gather all the users who are synced with the on-premises network, and the machines that are joined into the Azure, the applications that are registered with the Azure. There is a tool called Azure Hound, similar to that of the Bloodhound, that is used for enumerating the Azure. Once we populate the data, we can import it along with the on-premises Bloodhound file, so we could gain a broader overview of the on-premises network and their associated Azure tenant. Let's move on to the actual exploitation. So the first one is password asynchronization with Azure AD Connect. So what is Azure AD Connect? It is basically an application designed to achieve this hybrid identity, as we discussed. And when Azure AD Connect is configured with password asynchronization, it creates two service accounts, one on the on-premises AD, the other one on the cloud. So the service accounts have the following naming conventions, where in Azure AD it is followed by sync, followed by the server where the Azure AD Connect sync service is running, followed by the random string at the tenant name. On-premises AD, we have a username with MSOL, followed by a random string at domain name. So usually these passwords are stored in the database or LSA secrets present on the Azure AD Connect machine on the on-premises network. These accounts are high-value targets. Why? So these sync accounts are created solely for the purpose of synchronization. Sync account is assigned the role of directory synchronization accounts with the privileges to create, modify, and delete users on the Azure, including that of global administrators. On MSOL account, you have replicating directory changes, and replicating directory changes all privileges on the on-premises network, so you could do a DC sync attack. Here is the flow of password as synchronization. A user with password 1 can access the resources on the on-premises Active Directory, and he can access the resources on the Azure Active Directory with the same authentication material. The password asynchronization can be taken care by the Azure AD Connect, which synchronizes the password between on-premises Active Directory and Azure Active Directory. So how to target these servers? Bloodhound would be the right tool to look for MSOL accounts. Basically, these MSOL accounts have the host names in their descriptions where the Azure AD Connect sync service is running. Look out for multiple combinations of words like sync, AAD, CLD, AZ, connect in the machine's host name. Many organizations will have the host names related to the purpose of the machine that is serving. Also, the machine running Azure AD Connect service might have an MS SQL instance exposed. So we can look out for ports with MS SQL services running mostly on 1433. Let's get into the actual exploitation. So still organization store the service accounts passwords in LSA. If you have a domain administrator privilege or local administrator credentials, we can easily dump the LSA, which might get a clear text password of this AD sync service that is running. Now here we are using AAD internals to dump the synchronization credentials. This is just a list of commands which we can use to exploit. I will quickly move on to the demo where I can show you all those stuffs.
Before moving on to the demo, I just want to poke in some of the disclaimer points. So here we have assumed a scenario wherein you are already compromised the on-premise network and you have the administrator privilege on the domain. And of course, organizations would have EDR solutions to prevent the lateral movement and malicious activities. So this is an assumption where you have already bypassed the EDR or the AV solution that is present on the network. And so these are the two disclaimers before the demo. So
Yeah. So first, we are going to import AAD internals into the PowerShell. Then we are going to dump the sync account credentials. Once we have the synchronization account credentials, we can use that to create a credential blob and request an access token for us and save it to the current PowerShell session. As you can see, we got the access token. Now we have a valid credential, valid authentication material with which you can query the Azure Active Directory. Now we are going to look out for who are all the domain global admins. Our target account would be CSW. For exploiting this, we just need an immutable ID, which is a unique string for every users that are present on the Azure. So for getting that immutable ID, you just need to query the users. As you can see, we are able to get the immutable ID and the corresponding user principal names. So since now we have the immutable ID, we can just provide that immutable ID as an input. So for proof of concept, we are going to change the property name to display name from CSW to I have been hacked. So now you are going to just provide a source anchor, the immutable ID, and the display name what you need to change. Once that is done, you could see the result has been success. And you could see that this display name has been changed to I have been hacked, which demonstrates that you have full control over that account, which is a global administrator. So you could just change that password or even reset MFA so that you could gain full control over that account. Yeah.
So moving on to the next authentication method that we're going to discuss in exploit is seamless SSO. So seamless SSO basically stands for seamless single sign-on. So this enables the users to authenticate to Azure without requiring to type in their passwords or the usernames. And this basically works when a corporate user is connected to the network and he or she is allowed to directly access the Azure without the need for password. So this mechanism can only be combined with password hash synchronization or pass-through authentication, whereas with Active Directory Federation services, you cannot combine or you cannot enable seamless SSO. In this mechanism, there is a computer account called Azure AD SSO AAC is created on each of the domain at which the synchronization is enabled. And this account basically acts as the Azure Active Directory in the on-premise network. So when a user tries to access an Azure resource who is already logged on to the corporate network with a valid domain credential, a request for the Kerberos ticket of this account is made, and it's on the on-premise network. So the validation is sent to the domain controller, and once the request is validated, a valid Kerberos ticket is generated and returned back to the Azure. So this is just the protocol flow explaining how the authentication works. So here a user tries to access an Azure resource, and he is already signed into the corporate network. And for accessing the Azure, there is a request to the Kerberos ticket is made, and it is validated in the DC. And post-validation, the Kerberos ticket is returned back to Azure, allowing the user to access it. So this is just the exploitation commands. As I said earlier, you require the domain administrator privilege. Post that, you can directly dump the NTLM hash of this account, Azure AD SSO AAC, with which you would be able to forge the Kerberos ticket for any of the user. So let's now see the demo that we recorded. So for performing the DC sync attack, I'm using the well-known tool Mimikatz. So I'm passing the username as this account, and you could see that I have got the NTLM hash. And in order to target a particular account, you require a low privileged user on Azure Active Directory. So you import AAD internals again, and we create a credential blob of a low privileged user in Azure AD. And you save the access token to the cache in order to enumerate the global admins. So this is the global admin that we're gonna target. And you get their immutable ID, user principal name, and the SID which is present on the on-premise network. So you could see that since we are targeting the account CSW, we query the SID of that user account. And post that is done, you tend to create a Kerberos ticket with the SID and the NTLM hash of the account that we retrieved earlier. Once the Kerberos ticket is forged, you use this Kerberos ticket to get the access token on Azure AD. So it's stored in the variable AT, and with which you would be able to query the domain as a global admin. For the POC, again, we're gonna modify the display name of a global admin here, which is CSW. So you could see that we are trying to modify to I have been hacked, and we get the success here, and the display name is successfully modified too. So moving on to the next authentication method, which is pass-through authentication. In this authentication mechanism, the authentication request is transferred to the on-premise server, at which you have an agent running that is responsible for picking up the request from Azure AD and transferring it to the domain controller. So this agent, it's called pass-through authentication agent or PTA agent. And once the request is picked up, it gets decrypted by using the PTA agent's private key. And the validation is done at the domain controller. Once the authentication request is validated on the domain controller, a valid response is generated and sent back to Azure via this PTA agent. So this is again the authentication flow. Talking about the exploitation part, it's a bit tricky here since you need to target this PTA agent and its associated process. The process name is Azure AD Connect Authentication Agent Service, and in order to grab the credential from these agent, you need to have some sort of injection in place that monitors the credential from these authentication requests. So for that, we use PTA spy module, and this would basically inject a DLL into the process, and with which you would be able to monitor all the incoming authentication requests. So again, we're gonna see the demo. So here we try to install the PTA spy module, which basically injects the DLL into the process, and you could see that we have a success, and injection is successful, and we would be able to grab the credential from this place. So this is very stealthy because the user would not be aware of this injection or the MITM that is in place. Normally, when a user from this tenant accesses a resource, he just enters the username and the password. And no such things. And here the user simply accesses the Azure resource, whereas in the backend you have the credential being sniffed and you would be able to view it with this command. Yep. So talking about the last authentication mechanism that we're going to see and exploit is ADFS. So here, the authentication is based out on a trust between the on-premise ADFS server and Azure Active Directory. And both the authentication and the authorization is based on a security token, which is SAML token. And it contains all the information about the user's privileges, their user principal name, and all the immutable ID. So this SAML token is generated on the on-premise ADFS server, and it's signed with a specific token signing certificate. And this token signing certificate is only present on the on-premise ADFS server. So if we can retrieve that ADFS certificate with the administrator privileges that we have, we'll be able to forge SAML token for any of the user, including global admins. And here is the authentication flow. Here we have two of the scenarios. One is user who is connected to the corporate network and who is present locally trying to access an Azure resource, and another one scenario is a user who is present on the internet trying to access an Azure resource. So in the first case, when a user tries to access the Azure resource, he or she is redirected to the on-premise ADFS server. And once the valid set of credentials are entered, a SAML token is created, and the user is redirected to the Azure resource along with this SAML token. Whereas in the second scenario, the user is redirected to a web application proxy that is exposed to the internet, and it's of course connected to the on-premise ADFS server. And here also, once the credentials are entered, it's validated and a SAML token is generated and it's sent back to Azure. The user is redirected to the Azure resource along with the SAML token. Again, as I said earlier, in terms of the exploitation, hoping that you have already compromised the network or at least the ADFS server. With that privilege, you will be able to dump the token signing certificate that is responsible for creating the SAML token. So again, we'll be using AAD internals here, and we have also prepared a tool that remotely dumps this AADFS certificate. So let's now jump onto the demo. Before seeing it, this was recorded on a live engagement, so I have masked few of the sensitive information. Sorry for that. So you could see that we are running as the administrator in one of the ADFS server, and we use this command to export the ADFS certificates, and that is also successful. Once it's done, we identify the identity provider of this ADFS server, so which is this endpoint, and with this and the immutable ID of a particular user, you would be able to gain the session with the forged SAML token. So in order to enumerate the global admins, we log on with a low privileged user on the Azure Active Directory. So this entire thing is masked because it's a client. So we identify the list of global admins, and we wanted to target one of the IT admins. So these are the list of users along with their immutable ID. It's quite a big organization. So this was the account that we are targeting, and so this is the command which impersonates the global admin. So here we open an Office 365 portal as this user whom we are trying to impersonate, and we parse this ADFS certificate that we dumped along with the IDP. So this would directly open the Office 365 portal impersonating that user. So you could see that it's opened on an incognito mode on Edge. So we now move on to Azure AD. So this is the Azure Active Directory of this client, and you could see the number of users and groups, devices that we had control on. So we went on to create a global admin on this tenant, and we identified that this root tenant had few more subdomains in it. So post compromising or getting the global administrator, we were also able to laterally move into other networks. So you could see that these are the domains that we laterally moved, and there were 2 other domains. So we also said we have a remote tool. Let me show you that demo. So this is still under the development. We have now implemented only the remote dumping of the ADFS certificate. We are planning to integrate other authentication exploitations too. So so this target is basically the ADFS server, and this is the administrator credential. This can either be the local administrator of ADFS server or the domain admin. Both would work. Here you could see that we are trying to retrieve the ADFS configuration. Once that is done, we are querying the domain controller to retrieve the decryptor value. Post that, we are decrypting the ADFS configuration, which has the ADFS encryption certificate and ADFS signing certificate. So with this private certificates, you would be able to create a SAML token and impersonate any of the global admins that I showed earlier demo. So moving on to the final part, which is bypassing controls and mitigation strategies. Organization would definitely have the mitigation strategies in place, such as they would have restricted or enabled MFA on global admins, so preventing you to access the global admins account, though you had the plain text credential of the users. So there are some tweaks and techniques that can be used to evade these. One is you can look out for accounts that has similar privileges of a global admin. You could see that there are around 5 other roles which has the similar capabilities of a global admin, password admin, help desk admin, that has the password reset capabilities. of particular roles. So you can target these accounts. I'm sure it's a cool thing to look out for, since they might have disabled the MFA too. And one other thing to look out for is service accounts that has the domain admin privileges on the on-premise network. So enabling MFA for these accounts would disrupt the cause, because it's just service accounts, right? If you enable MFA, you won't have the service or the synchronization running. So look out for these accounts, and enumerate Azure and identify Azure accounts that has special privileges like AZ reset privilege or AZ add secret. And like we showcased in our tool, use RPC calls or remote queries such as WMA query or querying the mission via 445 to dump the AD Connect sync credentials or the ADFS certificates. So this would basically allow you to stay under the radar of an EDR. Since you are performing all the tasks remotely, you won't have many of the EDRs that is scrutinizing your actions. So this is one of the interesting encounters that we did on a recent engagement. So here, though we had the plain text credential of a global administrator, we weren't able to log in into his account since he had MFA enabled. But we did not stop there. We enumerated Azure, and we identified there was another user who had reset privileges on all the accounts, all the users, including that of the global admins. And this guy was a IT contractor. So we did not stop there. We went on to reset the password and reset the MFA settings of this IT admin. So here we had the password hash synchronization implemented along with the seamless SSO. So we forged a Kerberos ticket as this user using the NTLM hash of that account, and we got the access token. Post which, just to play around with this account, we sent out an Outlook email to ourselves impersonating this user. So our future work, or the things that we are currently researching on, is to laterally move into other cloud service providers. So we were able to do so, and we were able to exploit synchronization service that was running on Google Workspace. So once after that, we were able to log in into Workspace as a administrator. We had all the privileges. I mean, we were able to deactivate a user, delete a user, and we are still exploring the ways of escalating into AWS space. So our plan is to explore all the targets or all the authentication methods irrespective of the cloud service provider, and we wanted to integrate with our tool. So post the completion of this research, I'm sure that this tool will be available publicly.
As of now, it is in private. So if you guys want access to the tool, you can just contact us. We'll provide private access to you.
Just a quick note about our company. These are all the services that we provide. You can obviously reach out if you need. So thank you. And we have got some goodies for the attendees. So if you want to come and check it out, and we'll be able to provide t-shirts. So do check out with us.
Yeah, if you have any questions, feel free to ask us.
Any questions? No? Okay, thank you guys so much.
Thank you.
All right, please join us back here again in about 25 minutes for the final talk. Thank you. After this talk, please keep your seats, as we will have the CTF Awards and wrap-up ceremony directly afterwards. Thank you. And now, please join me in welcoming our next speaker, or Yair.
Okay, so are you all ready for the last talk of Security Fest 2023? Everyone are ready? I need you energized with me, okay? Okay. So, my name is Yair, or like the condition, okay? And today I will show you how I managed to turn EDRs and AVs into malicious wipers using zero-day exploits. So, as I mentioned, this is me. I'm a security researcher at SafeBreach, 23 years old. 5 years in the cybersecurity industry, started my way in the IDF, did some Linux and embedded research, along with some Android research as well. And for over 2 years, I've been doing a lot of Windows internals research in SafeBreach, and I just really, really enjoy it so far. But what are we going to talk about today? So, we're going to start with me talking about the initial research goal that I had in mind when I started this research. Then we'll talk a bit about wipers in general, see what they are, how do they work, and what they are used for. Then we'll deep dive into the technical aspects of the research process itself to see how I managed to find the zero-day vulnerabilities that allowed the creation of Aikido wiper. I promise that I will explain the uses of Aikido in the rest of the talk. So, the initial research goal that I had in mind was to create some sort of a next-generation wiper. I wanted to take wipers to the next level. But in order to create a next generation of anything, one must first understand the current generation, of course. So let's talk a bit about wipers in general. The first thing you do once you want to understand the definition of something, of course, is that you look it up in Wikipedia, right? So when you look up wiper in Wikipedia, it tells you that a wiper is a very sophisticated device used to remove rain, snow, ice, washer fluid, water, or even debris from a vehicle's front window. But of course, this is not the wiper that we're going to talk about today, and we are going to talk about the wiper malware. And just to make this clear, I'm sure that you are all familiar with wipers if you are attending this talk, but in computer security, a wiper is a class of malware intended to erase the hard drive of the computer it infects, maliciously deleting data and programs. But what are wipers? Why are wipers used? So that is probably something that you are also familiar with. But again, just let's make this clear. So basically, it's just to damage a certain entity. Doesn't matter if it's a state, company, any other organization. The goal is to cause damage to the entity. And you can also see I attached a few examples from the recent years with both Ukraine, Russia, Israel, Iran being attacked by wipers. Also some government-related organizations, so yeah. But this is not what we are here to talk about. We are here to talk about the technical aspects of wipers. So before we do that, we must understand a crucial difference between the word deletion and wiping. That is because deletion is a word which is very much associated with wiping, but they are actually two very different things. So let's take a look at the deletion process in Windows, for example, to understand that. Once a certain process in Windows calls the delete file API function, basically it causes the kernel to go to a certain place on the hard drive that is called the MFT, which stands for the master file table in the NTFS file system. And in this table, it just marks a certain entry as free. Now, this entry is just a pointer to the original file content. So the file content itself is not really being deleted when we delete a file. And that is the difference between a deletion and a wipe. When we say that we wipe something, it means that we actually delete the content of the file itself, and we are making it impossible to restore. But there is a way to escalate a deletion to a wipe. That is because, of course, MFT entries, which were marked as free, may be reused again, because otherwise we will be running out of disk space in no time, right? So when we create a new file, the file can be given an MFT entry which was marked as free, and then new content which will be written to the new file will basically overwrite content of deleted files which were left on the free space on the disk. But when I try to understand how do wipers nowadays overcome this gap between a deletion and a wipe, I saw that most of them actually don't even delete files. Instead, they just go ahead and overwrite files. By overwriting files, they are making sure that they are replacing the content of the file with different content, and then they are really wiping the content itself. They are removing the content. So this technique is used by very famous wipers that we all know, just we can see in the slide, some also from the very recent years. And basically, wipers can use this technique for user files only if they are not running as administrators, but usually wipers do want to cause the computer to be unbootable and delete also more important files that belong to an admin. So usually wipers need admin privileges for using this technique. Another very popular technique by wipers is the drive destruction technique. So we also see that a lot combined with the file override technique. And basically this technique means that the wiper opens the hard drive as a device and it starts writing directly to it. By doing that, it can overwrite boot structures, overwrite structures that belong to the NTFS file system, and files themselves. Now again, this technique is used by famous wipers that we all know, some also from the very recent years. And of course, Windows does require administrator permissions to write to the hard drive as a device. But after learning about these techniques, or any other technique that I learned about reading about wipers, I noticed one very important thing. And that is that each of the techniques that I learned about was obviously initiated by the process of the wiper itself. So for example, if we will open process monitor while a wiper that uses the file override technique is running on the computer, then we will see a process that opens and writes to a lot of files, right? And that sometimes can be legitimate, but it's very much incriminating too. But what if the next generation wiper that we will create will be able to maybe use API calls which are not extremely incriminating and obvious? And what also, as opposed to all the other wiper techniques nowadays, the next generation wiper will be able to run as an unprivileged user. At that point, I thought about Aikido. Now, Aikido is a martial art that specializes in using the power of opponents against them. But how is that even relevant to this talk? It's relevant because EDRs have a very special superpower, and that is the ability to delete almost any file on the system, no matter the required privileges, because they must be able to do things, right? They are running with high privileges. But before we understand exactly how we can Aikido EDRs and AVs into deleting our target files as an unprivileged wiper, we first need to quickly talk about when do EDRs and AVs choose to delete files. So of course, it depends on the configuration, right? But the most default configuration that I saw on most EDRs is that they choose to defaultly delete or quarantine files that are detected as surely malicious based on a static signature, right? Some EDRs do that when detect these files when they are open. Some detect them when they are closed after they were written to. And all EDRs and AVs mostly suggest an option for a custom scan of a custom path or just a general system scan. And now we can start thinking about how we're going to Aikido EDRs. And at that point, I had another very important insight, and that was that step 1 is already complete. And that is because even as an unprivileged user, I realized that I can already trigger the deletion, right? As an unprivileged user, I am able to create a malicious file. So once I'm creating a malicious file, I'm triggering the EDR to detect it and delete it. So all that I'm really left with is that I need to trigger that very same deletion for the wrong file. And once you think about it like that, the first idea that comes up to mind is to maybe just write some malicious content to an innocent file and then wait for that content for that file to be deleted by the EDR, right? But on second thought, this is not so good because, again, it requires write permissions, just like the file overwrite technique. So we will not be able to run as unprivileged user for all of our goals. And it also very much looks like the file overwrite technique if we'll look at the API calls. So the second idea was to maybe somehow point the EDR towards a different path while it still thinks that it deletes the original path. And these kind of vulnerabilities are usually achieved using links. And the link vulnerability category is very well known already in our industry, CWE 59. We are so familiar with it. Microsoft even know that they must have a special user right for that, which is given by default only to administrators. But the funny thing is that on the NTFS file system, we have 3 types of links. We have hard links, symbolic links, and we have another thing called junction points, or in short, junctions. Now, we can think of junctions kind of like a hard link for a directory, but the funny thing in here is that junctions do not require any special permissions to create, and from a high-level point of view, they work exactly the same like a local directory symlink. So I understood that if I want the wiper to run as an unprivileged user, I should probably use junctions to my advantage, but I still needed to understand exactly when and how. I needed to find the right window of opportunity. And what I thought of was that in the process of file deletion by an EDR or an AV, there are 2 primary events. There is the time in which the file is being detected as malicious, and the time in which the file is being deleted. Between these 2 events, there is a potential gap. I will maybe be able to somehow exploit this gap using junctions to point the EDR towards a different one, towards a different path. So let's see what was my original idea and how this can be potentially done. Let's say that as an unprivileged user, we are interested in deleting a system file, which is a driver located in C Windows System 32 drivers, and is called andthis.sys. Now, what we can potentially do is to create a path which is very, very similar to the path that we want to delete, just with one main difference, and you can see the temp directory on the right, which was created by an unprivileged user, us, and we can control. So we created ctemp Windows System 32 drivers andthis.sys, and then we placed malicious content, let's say Mimikatz, inside the new andthis.sys file that we created. But if then just before the EDR deletes the file, after it detected it, we delete everything from inside the temp directory and convert it to be a junction that points towards the C drive, then the same path that EDR tries to delete actually leads to the original end.sys file, right? So that is exactly what I try to do. I try to create mimikatz in the path ctemp Windows System32 drivers end.sys. Then immediately after I created it, delete it with everything inside the temp directory, convert it to be a junction, and wait for my target file to be deleted. But that did not work, actually. So I saw two primary behaviors. The first one was that some EDRs just had a very good grip on the file after I created it, so I was not even able to delete the mimikatz file. And so I was also not able to convert the temp directory to be a junction because it needs to be empty for that. And the second behavior was that some EDRs just realized that after I deleted the mimikatz file, there is no longer a threat because I deleted it. So at that point, I understood that the potential gap that I thought about does not really exist, and I need to somehow expand it. So what I did was to use a technique called handle catching. So for those of you who don't know, when we open a file in Windows, we use the create file function, and we get back a handle. Now, when we do that, we need to specify one parameter that is called the file sharing mode. The file sharing mode specifies whether other processes should be able to read, write, or delete the file that we are currently opening or creating. And as long as we keep the handle to that file open, then other processes are enforced, their access is enforced with this file sharing mode that was specified. So what I did was to create the malicious file, mimikatz, with a read-only file sharing mode. That has allowed the EDRs and AVs to detect the malicious file, but not to delete it. And of course, I kept the handle to it open. Once I did that, EDR started to pop up messages that tell me that I need to reboot my computer in order to fully remediate the threat. That was their solution to make me close the handle. Now let's take a look at how they implemented it. There were two ways. The first one was that some products used a Windows API for postponing a file deletion to after the next reboot. For example, Sentinel-1. And other EDRs and AVs just self-implemented it, meaning they kept the list of files to delete after the reboot somewhere, then after the reboot, they did it. Let's focus on the Windows API for postponing a file deletion. So it is done using the function moveFileEx with the flag moveFile delay until reboot, and that flag does require administrator privileges because once this flag is given, then this function goes to a registry value called pending file rename operations, which requires administrator privileges to write to, and to that value, it just adds a string, which is the path to delete after the reboot. Not the hash of the file, not any metadata of the file, just the string of the path. So the ridiculous thing about EDRs using this feature to postpone file deletion is that pending file rename operations blindly follows junctions. And so do other self-implementations by EDRs and antiviruses. And so overall, I was able to combine the two methods I talked about with the creation of junctions between the two primary events of deletion and the handle catching technique into one complete process that has allowed me to delete almost any file that I wanted on the system as an unprivileged user. So if we'll talk about the end.sys file example again, we'll see that the process creates with the process starts with creating a malicious file in the path ctemp Windows System32 drivers and the stats, then holding the handle to it open with a file sharing mode of read only, and wait for the EDR or the AV to give up on the deletion and postpone it to after the next reboot. Then, once the EDR has given up, we can delete the temp directory, create the junction instead, and reboot the computer, and after that, the original and the stats file will be deleted. By doing that, we've achieved the two what-ifs that I talked about in the beginning of the talk, and I promise you that any other edge case that you're currently thinking about will be answered in the rest of the talk. So overall, this has led me to find zero-day vulnerabilities in 6 different products. The products are Microsoft Defender, Defender for Endpoint, Sentinel-1 XDR, Trend Micro Apex 1, Avast Antivirus, and AVG Antivirus. 3 out of the 5 vendors that I just listed are actually high up in the leaders section of Gartner's Magic Quadrant for Endpoint Protection Platform in the year 2022. Overall, it is 4 vulnerabilities because Defender and Defender for Endpoint share the same mutual vulnerable code, and apparently also, I didn't know that before, and Avast and AVG belong to the same vendor called Gen and also share the same mutual code. These are the CVEs, so I was granted 3 CVEs, and Sentinel-1 chose to not issue a CVE. I do have one disclaimer regarding the vulnerability in the Defender products, and that is that I was only able to achieve arbitrary directory deletion and not arbitrary file deletion. But as you probably know, wipers do not really care about deleting a few extra files on the way. So if the wiper wants to delete a certain file, it can just delete its parent directory. Now, we have our first demo for this talk. And in this demo, we will see the exploitation against the Defender products. We will not yet see the wiper in action, but just the exploitation, with an attempt of deleting all the drivers in Windows as an unprivileged user, of course. So let's take a look. So here we can see the drivers directory with dozens of drivers inside. Then we can see that I'm running as a user called limited, and limited belongs to the unprivileged normal users group. Now we can see that limited creates the path temp Windows System32, and inside it creates a file called drivers, just like the drivers directory, and it holds the handle to it open with the file sharing, with a read-only file sharing mode. Then limited asks Defender to scan that path just to rush the process and to remove that file, which all can be done as an unprivileged user. Then we wait for Defender to give up, to tell us that it wants a reboot. It already has given up on the deletion for this session. Limited can now delete the temp directory, create the junction instead towards the C drive, and let's see what happens after the reboot. Okay, so almost all the drivers are gone from the drivers directory, and that is because Defender iterated through all the drivers until it encountered one that it could not delete for the same reason of file sharing mode. But most of the drivers are gone, and on the next reboot, Windows cannot longer boot. Thank you. So this exploit for all the security products is applicable also to bypass a ransomware protection feature called the controlled folder access. Basically, this feature in Windows prevents untrusted processes that are not in the trusted in the trusted processes list of that feature from modifying or deleting any file that is located inside one of the protected folders, which is also a list that belongs to this feature. But the thing is that in the flow of this exploitation, the process that deletes the file is the most trusted entity on the system, which is the AV or the EDR. So the controlled folder access feature is not going to prevent any EDR or AV from deleting a file which it thinks is malicious. So yeah. Overall, I tested 11 different products. 6 of them were found to be vulnerable, so that's more than 50%. And not only that, I was just unable to force the other products to go into that flow where they postpone file deletion to after the next reboot. So if you find a way to do that, or if you work for an EDR or AV vendor, or if you're a security researcher that wants to find vulnerabilities, I really encourage everyone to go and check these flows of postponing file deletion to after the next reboot before real attackers find these vulnerabilities. And now to the actual Aikido wiper tool. So I implemented it with the exploits of Sentinel-1 XDR, Defender, and Defender for Endpoint, just because their exploits were most consistent and easiest to implement. Also, all I really needed is a POC. The wiper is able to make the system unbootable, just like we saw in the demo. It is fully undetectable because it deletes files using the most trusted entity on the system, in our case, the EDR or the antivirus, which is in charge of detecting wipers. And in order to minimize the noise of the creation of a malicious file, the wiper also uses and creates the ACAR test file, which is not a real malicious file. Now the wiper is able to run with permissions of only unprivileged user, just like we saw in the demo. And it is able to delete important data. And it can even delete an entire admin user directory, which we will soon see a demo of. But if you remember, in the beginning of the talk, I explicitly mentioned that there is a crucial difference between a deletion and a wipe. So I still needed to somehow overcome this gap. But the solution for that was pretty simple. All I needed to do is to implement a feature in the wiper. So after the reboot, it just creates a huge file on the disk, fill it with random bytes, and by that it just overwrites content which was left on the free space of the disk from deleted files. I also made sure with 2 popular file recovery tools that I found online, which are called Clever Files Disk Drill and CCleaner Recuva, that they were able to recover some of the files before I implemented this feature, but after that they were not able to recover any file whatsoever. Now, another thing that I'm sure you asked yourselves is, but what happens if the default configuration is to quarantine files which are malicious? The user can just later go to the EDR's interface and restore those files, right? But the solution for that was actually pretty simple too, and a bit funny. And that is that I just exploited the vulnerabilities against the quarantine folder itself. And that has led the EDR to try and quarantine the quarantine directory. And so it just deleted it. So good for us, I don't know, or not for the EDR, for me. Overall, their repo is very well documented. I tried to document it as best as I could. Also invested some time in the design, so you really have my invitation to clone it, download it, expand it, find more vulnerabilities, again, before real attackers do. I'll give you a moment to take a picture, scan the QR code. You can also just look up Aikido Wiper GitHub on Google. You will find it on the first result. So I'll give you one more moment. OK. Now we have our second demo with the Wiper tool in action itself. In this demo, we will see the wiper deletes an entire admin user directory running as an unprivileged user, while the Sentinel-1 XDR is installed. So here we're logged in as admin. We can see that admin has a lot of files in its default libraries. Now we're switching, no, not yet, okay, just verifying that this is an admin. Belongs to the privileged administrator group. Now we're switching to limited again. Just making sure again, this is limited and it belongs to the normal unprivileged users group. Okay, now limited runs the wiper with the mode of proxy deletion of all user data of the user admin. We will see that the admin directory exists. This is the directory that holds all the default libraries. Limited runs the wiper. It exploits the right vulnerability for the installed EDR, also for the quarantine directory. Reboots a computer, and let's see what happens after the reboot. So the admin directory is fully gone. And now that we will look at the hard drive, it's also starting to fill up with data. And that is because the wiper was run silently after the reboot to start and fill the free space on the disk, only to make sure that the files are impossible to restore. Okay, so let's summarize all of this. After we've seen this talk, we've learned that a wiper or any other malware for that case can be much more dangerous if it uses an EDR or an antivirus or any security product to do its malicious actions by proxy. Now, for the 1,000th times, I'm sure you hear it every day, but please, having security controls does not mean that you are secure, so keep validating yourself every day. Now, security controls might also be a very preferred target for an attacker to find vulnerabilities in because they have very high privileges. And lastly, always assume that permissions can be escalated. I do have some vendor responses in here from Microsoft and Jen. I won't read them to you, but overall they were very cooperative. I have no complaints. It all went smooth. These are the versions that you want to make sure you have installed in order to be safe from this vulnerability. So you can see that there are all versions, and for the Trend Micro Apex 1 product, it's a patch, so make sure you have it. And I want to finish this talk with something very important that I'm still pretty scared of, and that is the pending file rename operation feature. Basically, we need to understand that each use of the moveFileEx function with the flag moveFile delay until reboot, or manually writing a path in the pending file rename operations registry value, if that is done with a path which is partially controlled by an unprivileged user, then we have created a vulnerability. And I know that not many developers are aware of that, so please let's try to raise the awareness for that together, or maybe, I don't know, just implement this kind of functionality in our own products and not use it. Lastly, I do want to thank Shmuel Cohen, which is a member in my team, for helping me to test my exploits against different AV and EDR products. And basically, this is it. We can move to the Q&A session. You can also have my LinkedIn, Twitter, and email. If you want to contact me later, I will be very happy to help and answer questions. So that's it.
All right, fantastic presentation. Do we have any questions in the crowd? Not that I can see. All right, thank you again so much.
Okay.
All right, now, the moment you've all been waiting for. Let's see if we have everyone from the crew and the CTF guys in the audience. Yes? I think so. Who's this guy? All right. I would like to take a moment to thank each and every one of you that came to Security Fest this year and made it all possible. I'd also like to thank all of our fantastic speakers. I think we should give them another warm round of applause. And of course, I'd also like to thank all of our sponsors and mainly our premium sponsor. This is intimidating, Mullvad VPN. Thank you. So, as you may know, we have had a couple of CTFs and challenges running during the conference. They have now wrapped up, so it's time to give out some awards. We're going to start with the second place for the main conference CTF. The award is 10,000 kroner donated to an organization or charity of your choice. And the award goes to Centur. Are they here? Somewhere? All right. We'll find them afterwards. And now, for the main event, this is sponsored by Mullvad. We have 5 of these Telitis T-key security keys. I don't even think these are on the market yet. And either 20,000 kroner in tech gear or 40,000 donated to a charity of your choice. And that goes to MSAB. You here? Get up on stage. Woo! Fantastic job, guys, as always. All right, so you can share these out amongst yourself. So how was the CTF? Was it good?
Yeah, it was very good.
Good. That's what we'd like to hear. Well, you guys are welcome back to try again next year. Maybe give the top spot to someone else. I don't know. We'll see. Anyway, thanks, guys, for playing. And, you know, good luck. Thanks. And we've had another couple of challenges. I believe we had a satellite hacking challenge. Do we have Falkwood somewhere? Please welcome to the stage.
Thank you. So we had a satellite themed challenge where we had a radio sending out signals whenever the satellites were over the horizon. And Jonathan was able to get 5 of those flags, which made him a winner. And that means Assured, the sponsor, give him one of those SDR kits. So congratulations.
Thank you. And let's see, do we have Kalle from Center here somewhere? All right. Please welcome to the stage.
All right, so we got the second place in this big CTF as well with some colleagues over there, but apparently we missed that prize ceremony. So let's do our own flag run. We had a number of participants. It was really funny. This year, Åke did most of the actual work. I'm just here taking the glory for it, I guess. But we need up on stage the winners of the yearly flag run. And on third place, we have the CERT SC team. Can we get these guys up? And on second place, we have the team name, which I believe is a Omega Point team. We need someone from there. And of course, on first place, we have the Stendals team. And by popular request, we're now going to explain some of the flags, where to find them, or how to find them, as we are bringing the guys up. Which team are you from? Certesi. Nice. You get a 500 crown check for Webhallen. The other guys, here we have the other guys, the Omega Point team. No? No, this is the Stendals team. Oh, excellent. You're the Omega Point, I recognize you.
Thank you.
Another 500 crown. And finally, the Stendals team. Excellent work, guys. So, very well played. Oh, so now to run through the flags. First flag, obviously, welcome to the CTF, was just on the booth, very simple. Rubik's Cube was the second most sold flag. Then one of the slushy machine, the Pixel Perfect, will you explain?
You do it.
Okay, so the Pixel Perfect was a pie cross puzzle on a paper where you do like a Japanese crossword thing. You filled in the pixels and then it said Pixel Perfect. Don't copy and paste. Oh, that you need to explain.
Yeah, so that's on the actual flag page. On the actual flag page, there are some rules. And one of the rules says, don't trust everything that you read. And if you have copied and pasted that, it would have been another string, basically.
Yeah. Font obfuscation. Pretty well hidden, ain't it? As a flag that was on the main sponsor booth. They allowed us to put a flag there. You found the phone number flag. Oh,
so another flag that I'm pretty sure that all of you have been staring at all this conference, and basically none have solved, is here.
Yeah, that's the, are you the next year's speaker flag? Do we have any solvers for that? No? Okay.
No. Vestberg had one in his presentation.
Yep.
We had one at the soldering station. We had one hard one, a Wi-Fi that you had to connect to and connect to the webpage. And then if you shaked Raspberry or similar, a new flag came up.
We had one over there, I think.
Yeah, we had one at the back that says back in the bus with all the cool kids.
This phone number flag.
Yeah, we have the barcode that's turned into a number. And if you do some OS ints and look up that number, that was one flag.
On hitta.se, yeah.
Yes. We had a voice one, an audio one, that if you reversed it, it was my voice is my passport.
Just hanging around.
Yeah, we had we always have one social engineering one. So if you ask anyone from Center if they have a flag, they give you a flag.
3 people figured this out. Only 3 people figured out you can just ask for a flag and you get a flag.
We had a crossword. We had another barcode that was inverted. We had one QR code. So most of these are QR codes that you scan, and one of the rules is that you are able to solve it with a mobile phone. And one that a lot of you struggle with, I know, turned into a hex. And if you hex decoded it, it was Center CTF OID. OID is object identifier. And if you look up, Center actually has an OID. Like you can have an OID as an organization.
And then we had one in the subject alternative name in the certificate of the website.
We had one on the well-known security.txt on the flag page.
Yeah, only one found that. No bug bounty hunters doing this. Oh, this you have to explain.
No, I want to say that to next year.
We have one solver.
That's me.
Ah, okay.
So I was a little bit surprised that no one took it, so I had to verify, and it still works. So.
And no one did this?
No.
Okay, then we'll save it for next year. Okay, in that case, that's all the flags that people found. Thank you very much for fighting. It was great.
Wow, I mean, there are so many challenges at this con. I'm just happy that some people had time to actually watch the talks. And I think finally do we have Abanyav here somewhere to talk about the bad challenge? There we go.
All right. So the first year for the bad CTF. Last year we did the hardware village. It was just soldering and some of the electronic stuff that's going on. So this year I really wanted to bring that sort of a combined experience with the CTF coupled with soldering. So you do both the things, and in the record time, whoever does it will have something for them. So in the third spot, who is able to solder the badge and then solder CTF is Eric Stahl. If he's here, no? Okay. And the second spot is Jonathan. And the first spot, we have Oscar Gourmelius. So big round of applause for all these guys. So probably they are not here. So probably they are not here. So we'll get in touch with them and figure out something about the prizes. But yeah, a lot of people, I didn't expect how many people would show up, but a lot of people showed up, and really, really grateful. All of you had a great fun, I hope. And yeah, maybe see you next year and see what we can do more further. So thanks a lot, and thanks everyone who joined.
Thank you. Okay, and just finally, before we go, I'd like to please have the Security Fest team up on stage. And this guy. Who's in this? Should we reveal it? No, should we let it be a secret? All right, you can probably figure it out from who's missing on stage. All right. From all of us, thank you so much for joining us at Security Fest 2023. We hope we'll see you again next year. Thank you, it's been great.